Hello, Hi everyone, and welcome to this momentous day. It is the Great American Eclipse Day, and we're here with National Geographic and Airbnb on this live stream on Facebook, YouTube, and Periscope. My name's Cara Santa Maria, and I am a science communicator. I'm here to help communicate some of the science behind what's going on. But even more interestingly, I am here with a NASA astronaut. Tell them about yourself.
Well, my name's Terry Virts. I'm a former NASA astronaut and National Geographic author, and so excited to be here. It's amazing.
I am thrilled. Okay, so today is Eclipse Day across all of the continental United States, and we have some really fun stuff going on. This is going to be my conduit to you guys at home. I'll be able to answer all of your, not all of them, some of your questions that you send in. I know we're going to be a little overwhelmed with them. I'll be able to go through and see what you guys have to say, and we'll be able to read some of that stuff on air. Now, I do want to point out that there is a big difference between a total eclipse and a partial eclipse. We're in the path of totality.
Yeah, this is amazing. We're right almost in the middle of that path of totality. As the moon goes around the Earth, it casts a shadow, and the shadow is pretty small. It's only about 40 plus miles across. And when you have a total eclipse, that shadow goes right across the Earth's surface, and that's where we're going to be in just a matter of minutes.
I am thrilled. We're here in Terrebonne, Oregon, and right now we are in the phase of the eclipse between what they call first and second contact. We're actually already in a partial eclipse, and we have a live feed of that. You guys can see what's going on. The moon is already covering much of the sun there, and you can even see sunspots through this live feed.
It's amazing.
How incredible is that? All right, but I do want to talk about why we're here in this beautiful location, which feels like it's the middle of nowhere. It's in the middle of nature. You can see that there's this geodesic dome behind us, and this was a special prize for two very lucky Airbnb customers. So they got to spend the night in this geodesic dome, and then today they got to fly with a Nat Geo photographer and with an astronomer to chase the eclipse. So first they're in a helicopter, and then they're going to be in an airplane where they get to follow the eclipse.
So jealous.
Yes, so freaking jealous, right? And you can see them here. How exciting. Oh my gosh, such excited winners. I can only imagine what it would have been like to, I wish I had slept here last night.
I know, what an amazing place out in the high desert.
Yeah.
The stars must have been incredible.
I know.
It's beautiful.
But I gotta be honest, I stayed in a pretty dope Airbnb last night too.
It was pretty awesome.
Yeah, it was a lot
very
of
nice
fun.
house, yeah.
So I'd love to check in with Jedida Eisler, Dr. Jedida Eisler, who is the astronomer who went up in the plane with them, and Babak Tafreshi, who is the Nat Geo photographer. Let's see what they have to say.
Hey y'all, it's Dr. Jedida Eisler. I'm an observational astrophysicist and a lover of the night sky. I'm so excited about what's going to happen.
Babak Tafreshi, I'm a night sky photographer working with National Geographic and the founder of the World at Night program. So the whole life I was involved with night sky and a fan of astronomy.
So it's almost like we're doing the coolest thing one could do if one were going to watch a, say, once in a lifetime solar eclipse. We're going 35,000 feet in the air to watch the eclipse.
Yes.
In a private jet. Are you excited?
Yeah, that's the best place, I think, to see the coming shadow and the going shadow. And it's much faster than our plane, almost 6 times faster.
Yeah, it is. Yeah, it is. There's no way we're going to keep up with it. So all of those of you who are excited for us, we're excited too, but we're not going to be able to go with the shadow. It will pass us very quickly, but we'll still get a very unique vantage point that we're really excited to see.
Yeah, I think we get 15 to 20 seconds more totality by being on the plane, chasing the shadow. So it's slightly more than the ground. But the main benefit, I think, it's just to be among the first people to see it, probably less than 10 minutes before the others on the Lincoln Beach.
I love it. I love it. Yeah, I think that's true, right? Getting to see it early is always fun. I would watch it at any time, but if I could watch it at 35,000 feet, I will.
Every eclipse is different, depending on the ambient environment that we're seeing. It could be with some clouds, reflection of the clouds, colors in the clouds. It could be the shadow coming, could be people and their emotional reactions. So I'm going to include many of those in the opportunity we are going to have on the plane. We have guests, and probably it's their first total solar eclipse, so I'm going to capture those emotions, as well as close-up of the eclipse. As I said, you know, there's streamers coming out of the solar corona are better visible from our altitude.
They are.
But my main aim would be to capture this shadow coming, especially when you're up in the air, you see the cone of the shadow much more clear than being on the ground. So all these together, I think it will be a very diverse total solar eclipse for me.
So the next time you see us, we'll be 35,000 feet up, looking directly near the sun with our protective glasses on. We hope wherever you are, you get a chance to watch it or experience it in some way. It'll be fun. See you soon. Bye.
Oh my gosh, so excited. I'm really jealous that
I'm
they're
totally
up there in that
jealous,
plane
yes.
right now.
They will have bragging rights.
They will absolutely have bragging rights. Okay, so let's recap a little bit of what they mentioned. During a solar eclipse, it's really quite a simple concept. It's that the moon is in front of the sun.
That's
And
right.
we happen to be in that path, which is, there's a fun word for this. It's called syzygy. Syzygy. I said it, I always say it wrong. Syzygy. And that's when the planetary bodies align just
Right.
so perfectly. And most of America is actually in what they call the penumbral shadow, which is the almost umbral shadow, the
Right.
large shadow
Right.
that's cast down. And that happens during a partial eclipse. Most of America is in a partial eclipse.
Right.
There's a skinny line, you said earlier, 40 plus miles
Right.
across. That is the totality line where you'll be able to see the sun, or the sun be completely blocked by the moon.
That's right.
Now, these different phases require different types of protection, so maybe we should do a quick safety
They do.
lesson.
We'll do a demonstration.
Yeah.
So don't do this unless you have some approved glasses on. But I'm going to actually look at the sun
Mm-hmm.
with the approved glasses, and you can see, it's amazing. You can see the moon has taken a significant bite out of the sun right now with our
Wow.
glasses.
Wow, I have to just point out real quick that my safety glasses are a little cooler than his
Yes,
safety glasses.
again, bragging rights. I'm losing all the bragging rights here.
And we should mention that they need to be ISO certified glasses.
That's
there
right.
are some fakes out there, which is a huge bummer. Why would somebody do that?
These are not normal sunglasses.
Yeah.
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 So, and also when you're in a partial eclipse, it doesn't make the sun any worse. It's not more dangerous than it is on any day. But on a normal day, you're not going to stare at the sun. And when there's an eclipse, you're interested to see what's going on up there. That's why it's more dangerous. It's just the likelihood of you actually staring at the sun.
Absolutely, and the closer and closer that we get to totality. So if we look at our live stream right now of the sun, you'll see that it's a big bite has been taken out. The moon is really covering a bunch of the sun, but as it gets closer and closer to the sun being a sliver, it might not feel as much to your eyes
Right.
like it hurts if you tried to look at it. It might not feel as bad. And that's when it's the most dangerous because you won't have that natural inkling to squint.
Right.
And you should never look at the sun. The sun
Right.
is way too bright. It will damage your eyes. So
Even
eye
if it's
protection.
90% covered.
Exactly.
Even if it's mostly covered.
90% covered, you cannot look at it without
Right.
eye protection. You want these ISO certified glasses. There are also some cool toys out there, and maybe you already have them. It might be too late to get them if you don't. Like, I have a pair of solar safe binoculars, so I can actually turn up and look directly at the sun. Oh my gosh, and I can see sunspots. I'm freaking out right now, you guys. I'm going to be doing this quite a bit throughout this stream because I can't get enough of it. I can look directly at the sun with my binoculars. Terry's doing some incredible photography right now.
That's right, but I have a special solar filter on the front, so you do not want to look through a normal camera at the sun because that will be even worse than looking at the sun. It'll be like a magnifying glass focusing those dangerous
Yeah, you
sun
remember
rays.
doing that with a magnifying glass
Yes.
with ants when
And-
you were a kid? Ooh, but we all did that.
Yes, we did. So you don't want to do that on your eyeball.
No, absolutely not.
And if you happen to be in that narrow band of totality, once the sun is completely blocked and the moon is covering it up, then you can take your glasses off and it'll be safe for a minute or 2 minutes, however long you're in the path for. But until then, you have to have the protection.
Yeah, and so look it up, make sure you're in totality, and you'll know. I mean, it's a very specific look, being in totality, but that's the time when you can actually remove your eye protection. You can look straight at the sun because the sun is completely blocked by the moon, and all you can see is that faint corona. And the truth is, if you try to look at the sun with your protection, because these are so dark, during totality, you actually won't be able to see anything.
Right.
That's the moment. It's when the sun sets in the middle of the day. This is what I think a lot of people don't realize. In totality, it's going to get dark.
It'll be dark, it'll be cooler, the temperature will drop. Yeah.
Oh my gosh, I am so excited. Okay, so you have never, you know, the last solar eclipse was in 1979 here in
Right.
the United States. And so I've never experienced it. I was born in 1983. Have you experienced from the ground here on Earth a solar eclipse?
I have not. This is my first one.
But a little birdie told me that you have seen them from space.
So that was a really amazing opportunity. When I was on the space station 2 years ago, there was an eclipse over the North Atlantic. And as we were flying over, it was really far in the distance. It was more than 1,000 miles away. But you could see actually the shadow of the moon on the Earth. And if you look at this picture, there's a solar array from the Russian Progress spaceship there. So underneath that bright white rectangle, you can see the dark spot. And that is actually the moon's shadow. And it was so amazing to be in space, looking at my planet Earth in the distance and seeing the shadow from another heavenly body. It was truly a surreal moment in space.
I can only imagine. And
Yeah.
of course, you've taken how many photos from space?
I took over 300,000. I took a lot of pictures.
How is it that you don't have a coffee table book for my enjoyment?
Well, it's funny you should ask, actually. I have a book called View from Above. It's a National Geographic book.
Oh, great.
And it comes out this October. So it's a combination of some of the best of the, not all 300,000 pictures, but 300 of the best. And also stories from space, what it was like to be there for launch and landing, what it was like to be there during some emergencies that we had. So it's a combination of stories and photos that kind of take a space mission and put it in book format.
So you said it comes out in October?
October 3rd.
Just in time for my birthday. Just, just saying, October 19th. And the reason it's an easy thing to remember for me, totality, right where we are, starts at 10:19 this morning, which is my birthday. And right now, I'm just going to check, it is 10:42. So we're getting really, really close to totality. Can you believe it?
Another.
I said 10:42.
9:42.
But I meant 9:42.
Another 40 minutes or so.
Another 40 minutes or so, and I'm going to be doing a countdown. I have a great app on my phone that gives me a perfect countdown to totality. So we'll be doing a nice countdown. I know that Terry is going to try and get some good astrophotography.
Yes.
Would you call this astrophotography?
I think
it's
so.
It's like solar photography.
Yeah, there's probably a special name for it.
Exactly. So he's going to try and get some really cool photography while it happens. I think I'm just going to appreciate it.
Enjoy
but we
it.
will work on that countdown. So I want to maybe take a question from the audience here. You guys at home, of course, keep sending in your questions, your comments, because we're going to be able to check in with you throughout the stream. And remember, you can do that at National Geographic's Facebook page, or you can do it by using the hashtag NatGeoEclipse. And I've been using it, so you should use it too. All right, so we have one here from Brenda Troyer Harness, and she asks, what effect, if any, will the eclipse have on Earth's tides? Oh my gosh.
That's a great question.
But you know what? Here's the thing. The moon is in this fluky position anyway.
Right.
So it's a normal day for
Yes.
the moon, and it's a normal day for the sun. But there are some numbers that we should know, right?
That's true.
The Earth is, let's see if I get this right. You fact check me here. The Earth is 4 times larger than the moon.
Right?
The sun is 100 times larger than the Earth.
Correct.
So the sun is actually 400 times larger than the moon.
Right.
But the moon is
400 times.
closer.
Right.
Yeah, than the sun. Which means if the sun's 400 times farther away, but the moon is 400 times closer to the sun, in this super fluky coincidence, the moon looks like it's the same size as the sun and completely blocks it.
It does, for now.
For now.
But soon, in another 600 million years,
Soon, he says.
the moon actually moves away from the Earth a few inches a year.
No, it doesn't.
A couple inches a year.
That's amazing.
So in 600 million years, it'll be so far from the Earth that there won't be any more eclipses. So it's good to watch the eclipse while you still can.
Yeah, so when we say once in a lifetime, but really it is in many ways a
It
once
is.
in a lifetime
Yeah.
because eclipses are quite common. There's about 2 a year. They're usually partial. There's one total solar eclipse. What is it? About like every 3 or 4 or 5 years.
Every year or
something
two,
like that.
yeah.
Yeah, it does happen, but the problem is it's usually over the ocean.
Right.
It's not where you are.
Right.
And it's not usually in your country. So the same eclipse, like this eclipse that's happening today, or I shouldn't say the same eclipse, that gets confusing. An eclipse passing over the same GPS coordinates only happens like every 75?
No, it's over 300.
375
Yeah.
years. Which means if you never move, like if you don't have the capacity to travel to see an eclipse, this is it.
Yep.
This really is a once in a lifetime experience. We do have another total solar eclipse coming to the United States in 2024. So that's just in, what is that, 7 years?
A few more years, yeah.
Oh my gosh. And it's going to pass over where I grew up in Dallas, Texas.
Cool, that's right.
I'm
It'll be
really
in
excited.
Texas, where
I
I'm
get
from.
to go. Really? Oh
Yep.
yeah, you live in Houston.
In Houston.
Astronaut. So we do have another opportunity if you're missing it today. And also, maybe we should talk a little bit about the different ways that you can look at an eclipse. Because
That's right.
most of you watching on the stream are probably not in the US, or if you are in the US, you're not in the path of totality. So you're seeing a partial eclipse. It's a very special thing to be within that path of totality. I think you were telling me earlier, 1 in 1,000 people?
Yeah. I've seen the statistics, less than 1 in 1,000 humans ever get to see a total eclipse. So you're pretty lucky if you do. And even if you're in the path of totality, if it's cloudy, you're going to miss it.
That's true. There's
So,
some cloud
there's
cover
some cloud
today in some
coverage,
parts
yeah.
of the country.
Yeah.
So hopefully they'll be able to enjoy it here on the stream because we
Right.
have this wonderful telescope that's really powerful with a solar
amazing.
filter trained on it. So you can see, oh my, it's so crazy that you can see sunspots. It just blows my mind. But also the moon is occluding it. And something that I notice when I talk to a lot of people who have seen total solar eclipses is that you can't tell that it's the moon during the day, right? Because the sun is so bright that the moon, Terry's taking some photos, he's gonna be doing this throughout, that the moon, it really looks like this dark disk, almost like a hole in the sky. And as the moon actually covers it up, sometimes people get scared. They actually feel like the sky has ripped open and there's this hole that's coming at them. It's a very visceral experience. I have no idea what I'm gonna do. I might cry, just to warn you. I might cry, I might scream, I might be afraid. And also, did you know that animals act super weird during eclipses?
They do, yeah. They don't know what's happening. They think it's nighttime all of a sudden.
And so I was reading up on this. Dogs can sometimes get really scared. You'll hear that birds will roost. They'll actually go to bed for the night. Roosters will cock-a-doodle-doo when the sun comes back out because they're like, what is happening? But two things that I found super fascinating. Apparently cows don't notice. They just don't seem to have a reaction. And they found this out. Yeah, they found this out by doing a lot of cool citizen science during I think there was an eclipse in like the 1930s. And scientists asked people to watch their animals and take notes and write in and tell them what happened.
Wow.
And cows don't seem to notice. Chimpanzees, our closest cousins, will look up and actually
See what's
look
happening.
at it in awe.
Without glasses, though. That's the problem.
That's a huge bummer. They don't know about ISO
right.
protection.
That's right.
Oh, we need to get the chimps some
We do.
solar glasses. Oh, we need to start a new nonprofit
Right.
for that. So crazy. Animals are going to act strange. I think people are going to act strange. You know, we're here in Central Oregon where there's a lot of eclipse parties going on. Nearby in Madras, there's a big tent city basically happening where a lot of people are watching. And there's probably a lot of kind of discord outside during the eclipse because when you're in close proximity to a lot of people and you have these sort of visceral reactions, I can't imagine the interesting noises people are going to make.
My friend, fellow astronaut Don Pettit, is in Salem, which is on the west coast of Oregon, and the Oregon Science Museum is doing an event with 9,000 people. So he's going to be helping to host that. But we were talking last night about how he's going to film it, and he wants to film it with the noise so we can hear people's gasps and reactions. Yeah,
absolutely.
That's going to be cool.
Okay, so I just realized too that Brenda, we didn't fully answer your question. What effect, if any, will the eclipse have on Earth's tides? I would say don't quote us on this because neither of us are eclipse experts, but I don't think it's going to have an effect. It's basically a visual fluke, but the moon's in the same position it would be in anyway. Maybe we can talk a little bit about the cycles. So we mentioned 375 years, an eclipse will pass over the same spot.
Right.
Although there is an X marks the spot place on the map. I can't remember where it is, but if you live in this one town, you actually get to experience both total eclipses.
Oh, cool.
Lucky you. And so let's talk a little bit about the Soros cycles. This
That's right.
super cool. What is it, every 18 years?
Every 18 years, yeah, the eclipse repeats itself from a orbital mechanics point of view. And that leads to another question. I'm sure we're going to get lots of these. Why isn't there an eclipse every month? Because every month the moon goes around the Earth and gets between the Earth and the sun.
Yeah.
But the shadow is so small, so there's always the moon shadow. The moon shadow is somewhere in space all the time, 24/7. But the Moon's orbit is not in a perfectly aligned plane with the Earth's orbit,
So one
it's
of
a little
them's
bit
like
of
off
inclination.
kilter.
So
Gotcha.
every month the Moon is near the Sun, but it's usually just a little bit off above it or below it, and the eclipse passes just overhead. Yeah.
Dang it. But we do have, like we said, a couple of years, like eclipses are actually much more common than this,
Right.
but they're just not common where people are.
Right.
And they're especially not common where people are over and over and over again,
Right.
which is why for many people this really is a once in a lifetime
Right.
experience.
And this is amazing because everybody in America, not the continental U.S., yes, but even Hawaii and Alaska are going to be able to see at least a partial eclipse, which is great because it kind of brings us together.
I know. You know, sometimes, you know, whatever your politics are, whatever is going on in your life, there are divisions and there's difficulty. But when we get to see an event like this, you know, something that really reminds you of how small we are on
Right.
this planet, how we really share this planet together, and these cosmic phenomena are not concerned with us.
That's right.
They
yeah.
haven't regardless. It really ties us together. I feel tied together with you. I feel tied together with everybody across the U.S., everybody across the world who's watching this stream right now. The animals, all of nature around us, we all get to experience this together.
Yeah, it's really amazing. And, you know, the last few months there's been a lot of issues going on, and this is something that we can all share, and it can be a positive thing. The space station is like that. When I was in space, I was with Russian cosmonauts and an Italian and Americans, and we got along great, and we became great friends, still to this day. Even though things were happening on Earth, you can use these things to kind of bring you together. And I think that may be the best thing. The physics are interesting, the experience is interesting, but hopefully, you know, bringing folks together will be the most important thing that happens.
Absolutely. And people are getting together all over the country right now to celebrate. We actually have a photo here of some National Geographic staff in Tennessee who are getting ready. Oh, look at their t-shirts. I love it. Who are getting ready for the eclipse. And of course, we are on the early end of this because we're in Oregon, and the path of totality is moving west to east. So in many ways, we're some of the first people who get to experience this.
We are very lucky, and my friend on the TV in Baltimore, Fox 45, the meteorologist sent me the map. And so on the West Coast it's great, and in Tennessee it's great weather, but in the middle of the country there may be some clouds, and in South Carolina there may be some clouds. So, it'll still get dark out, but you won't be able to necessarily see the moon covering up the sun.
And that's when I say, luckily in 2024, we'll be able to try again. But okay, I want to take another question, I think. So we've answered this one. Let's see what else we've got. Okay, we've got one here from Kathy Evelyn, and she says, oh, we mentioned this, but I think we really should re-hit this. Would it be safe to point my phone camera at the eclipse and watch it on my screen? It seems like it would be a good hack, right? Well, I don't have to look directly at it if I just look at my screen, but...
If you're looking at a computer screen, that's safe, but if your eyes are pointed in the direction of the sun, that might not be good. And it might not be good to keep your phone pointed at the sun for a long period of time. You can take pictures of the sun, that's fine.
Yeah,
but if you just leave it,
is one thing. But if you're taking a video,
like for a long period of time, that might fry your electronics or melt the camera. Especially if you have, you know, a telescope or a zoom lens like this.
Or even binoculars. Like, again, I got to point out, these are solar safe. I don't know if you can see that, but these are solar safe binoculars. You can't, it's too bright. Which means that they have this super dark lens over the end that's cutting out all the radiation that could be damaging to our eyes. And I think another point that we should mention, what you don't want to do, if you got a solar filter and you're really excited to be able to use that solar filter, you don't put it between your eye and the lens that's closest. You have to put it between the lens that's farthest away from you, because this lens is magnifying the sun's rays.
That's right.
And it could tear a hole right in your filter if you put it close to your eye, or it could let some of those harmful UV rays in. So the truth is, all of these, the telescope that you see that's pointing at the sun right now, let's look at that picture again, because it just blows my mind every time. Oh my gosh.
That's amazing.
That's the sun, you guys. That's not the moon. That is the sun. That telescope has a giant solar filter on the large part of the telescope, the big lens that's towards the end, and that's what's protecting us. And Terry's camera that he's taking photos with right now, it has a big solar filter on the other side of the camera.
It's right in the front,
protecting him. Yeah, so we've just got to be really, really careful not to hurt our eyes first. That's more important, and maybe not to destroy all of our fancy electronics. All right, I want to see if there's another. Okay, here's one from Jessica Aguilar. She asks, can you turn your back to the eclipse and put a mirror in front of you like you were going to take a selfie and see it in the mirror?
So
Well,
a mirror would actually just reflect that. That's the way a lot of telescopes work, is with mirrors. So a mirror would be dangerous. If you watched a reflection maybe in glass, that would be one thing, or you could do a pinhole camera.
this is really cool.
Yeah.
So we can talk through. We don't have the supplies here,
Yeah.
but we can talk through it. If you wanted to make a pinhole camera, it's really, really easy.
Right.
You need a box. A box
Some
is helpful.
piece of cardboard or something like that. Yep.
A cereal box is actually really
Yep.
easy because it's just the
Perfect.
right size.
Yep.
And so what you're going to do is you're going to take a
screwdriver.
cereal box. Yes, you need a screwdriver. Foil is helpful, and a pair of scissors, and also some white paper, because I think
Right.
this is the important part. So you'll trace the bottom of the cereal box on a piece of white paper, and you'll cut out a sliver that's the same size as the bottom of the cereal box, and you'll stuff that down inside. Also, you should empty the cereal box, by the way. So the paper, the white paper, is going to be what you're looking at. You need that nice reflective surface, but it's not a mirror. That's
Right.
too reflective. And then you're going to cut 2 holes in either side of the top of the cereal box. You'll cover one of those holes with foil, but you'll leave the other one open. The other one is your viewfinder. You look through it. The one that you cover with foil, that's when the screwdriver comes in, or a pin,
Right.
hence pinhole camera.
Poke a small hole in it.
Poke that hole. That's going to collect the sunlight. It's going to actually reflect the image of the eclipse down on the white paper below, and you can see it by
Right.
looking through that viewfinder. So what you'll see, what we're seeing here through the telescope, which is a true image, you'll see a perfect reflection of that in your pinhole camera. So worry not if you do not have eclipse glasses. You still get to experience it.
You can.
Ah.
Team Moon is winning right now.
Team Moon is gaining on
Team
the sun for sure.
Team Sun is losing.
So totality is getting closer and closer to where we are right now. I'm just going to open up my app. So first contact started at 9:06. That's Pacific time. We're
Right.
here in Oregon. It started at 9:06. It's currently 9:56. So we have been first contact. Maybe we should explain that because we use those terms a lot. First through fourth contact.
That's right.
These are important kind of astronomy terms that,
Right.
that everybody uses.
That's right. So if you're looking at the sun with your approved sunglasses, and the moon is out there, when the moon first touches the edge of the sun, that's called first contact. And then the moon moves across. Right now, if you're looking at the feed, the moon is kind of taking a bite out of the sun. And when the complete moon covers up the sun entirely, that's called second contact.
So that's really the beginning of totality, second
Right.
contact.
That's
yeah.
right. And then as it moves across the sun, once totality ends, that's called third contact, and that's only about a minute and a half later here where we are. Some places it'll be seconds. For the longest in America, it'll be just over 2 minutes. That's third contact. And then the moon will move away. The Team Sun will start to be winning again.
Yep.
And when the moon finally moves away from the side of the sun, that's called the fourth
Fourth contact.
Fourth contact, yeah.
And so we're in between first and second
That's right.
contact right now. And it's between first and second and between third and fourth contact where you have to use that ISO approved solar protection
That's
for
right.
your eyes. In between second and third, which is totality, if you're lucky enough to be in the path of totality, that's when you can actually remove your eclipse glasses and marvel
Right.
in what is happening above. And the truth is, a lot of times when we think about the eclipse and we see images of the eclipse, these are images that are taken through telescopes or
Right.
taken through zoom cameras, and we're really looking at the sun and the moon with no context. But part of the joy and the awe of an eclipse is actually not looking at the sun, but looking around you.
Right.
It's going to be dark as night.
Right.
It's going to be cold. And the color, apparently, of the sky, of the ground, of your skin is a color that's almost indescribable because this is a type of quote-unquote night that we've never seen
It's not
before.
normal night, right? That's what I'm most excited about, to see what the color is. Here in Oregon, there is a forest fire nearby here.
Yes.
So there's a little bit of dust in the air. It's still a beautiful day. So I think that dust is going to make the colors really maybe orange. I don't know. We'll see. I'm excited to see that.
Absolutely. So guys, I'm really excited because we are able to get on the line right now with Andrew Fazekis. He is in Myrtle Beach. So totality is not as nigh for him there in Myrtle Beach, but he is a Nat Geo journalist. He writes about this stuff all the time, and he's going to be able to share some interesting stuff with us. Hey, Andrew, can you hear us?
You bet I can. Yeah.
Happy Eclipse Day. How you doing, buddy?
Oh, very good, very good. I'm actually on the beach. I'm actually south of Myrtle Beach now. I'm in the Isle of Palm. I made the trek down here. It's about an hour-and-a-half drive south. It's just very close to Charleston, right in the path of totality. And I'm in the middle of like thousands of people. I can't believe it. It's like, and they just keep coming onto the beach. I'm like, I'm really stoked because you could feel the energy around here. It's amazing.
That's incredible. So how is the cloud cover looking? Do you think you're going to have a clear shot?
It's not going to be clear, that's for sure. I can tell you that there's a lot of cloud. There's a high clouds. We're hoping for like this microclimate effect on the along the coast here, and I can't see the sun through this high deck of clouds. So if it stays the way it is, we should be able to see the sun and definitely darken. I mean, there's no question about that.
Absolutely. So Andrew, I wanted to ask you about an incredible opportunity that individual eclipse viewers have. You know, a lot of us were lucky enough to get our hands on a pair of eclipse glasses that we can use to view it. But, you know, once the eclipse is over, what do you do with those things?
Well, that's right. So some people are thinking, well, I might keep my glasses for the next eclipse, but that's in 7 years, in 2024. And the polymers that are used in the solar eclipse glasses aren't really able to last that long.
Oh, good to know.
And they're about 2-3 years lifetime. So if you're planning on putting away, it's just not gonna work. They're very inexpensive too, so you can always go out and buy that for the next one. So what the suggestion that Astronomers Without Borders, this amazing nonprofit, which, by the way, this full disclosure, I'm also involved in, because I love this idea of why not, instead of wasting your glasses, donate them to schools in Asia and South America that will experience their own totality full eclipse in 2019. And so this is a great way that folks can recycle their glasses and have another group of people on the other side of the world enjoy this amazing moment that we're all going to experience today.
That is such an incredible opportunity. You know, I have some paper glasses. I have these really cool eclipse shades that I'm rocking right now. And I would love to be able to contribute to the education of some school children in parts of the world where maybe it's not so easy to get their hands on this. So you said Astronomers Without Borders. That's who we can donate our glasses to?
Exactly. So astronomerswithoutborders.org. Online, you can go and visit them. They're going to be announcing very soon where and when to do so. Hold on to your glasses just for a little bit. Just hold on to it, and we'll be sending out instructions on where you can send your glasses into. And we'll have corporate partners who will help us gather them from across the country, and we're hoping to just send them en masse somewhere else so they can get reused with love. It's going to be an awesome opportunity to inspire youngsters into STEM, right? I mean, the eclipse is an amazing inspiration that'll spark, a whole generation potentially of engineers, scientists, astronauts even, right?
Absolutely. And guys, for a lot of you, it's the first day back at school. So what a great thing to do during your first day back. Hey, Andrew, I've got one more question I want to ask you before we go. You write for National Geographic, and I read your writing all the time. It teaches me so much about astronomical phenomena. I would love to know, what was your favorite thing that you learned and then wrote about when you were preparing for the eclipse?
For me, it's the first-hand stories of animal behavior. It is absolutely incredible how nature responds to an eclipse, a totality, particularly that only lasts for a precious few minutes. Animals do respond. Everything from whales, dolphins, to small insects, ants, and even spiders. Some spiders destroy their webs during those precious few moments of totality. We don't even understand.
Oh, wow.
Exactly.
Wow.
Yeah. So there's a lot of things, and there's actually a cool app out there called Life Responds. It's through iNaturalist. It's by the California Academy of Sciences, and they, if you download this free app, they're collecting your stories from across the country of what you're seeing in wildlife around you. It could be ants, or it could be birds, whatever you're seeing, and this will be used by scientists, by behavioral ecologists to understand how wildlife really responds.
That's incredible, guys. You should contribute your knowledge. If your dog is freaking out, let them know. Andrew, thank you so much for checking in with us.
You bet, and I wish everyone clear skies.
Definitely. And happy eclipsing to you as well. Well, guys, if you are just joining us on the live feed, I'm Cara Santa Maria here with former astronaut Terry Virts. This is kind of my most special, happiest day of my life, I gotta be honest. And we're here in Terrebonne, Oregon, viewing totality. We're getting closer and closer to totality. We're in a partial eclipse right now. We are here with National Geographic and Airbnb. We're live on Facebook, on Periscope, and on YouTube, and we are taking your questions and comments. You just can reach out through the National Geographic Facebook page or on Twitter using the hashtag NatGeoEclipse. It is 10:06 a.m. Pacific time.
We're minutes away.
Yeah, in 13 minutes.
Right.
Can you think of any other cool eclipse things that you learned when you were studying up?
Well, I would say if you're on the west coast of America right now, you're in a partial eclipse.
Yeah, it's true.
So it's here, but don't do this without a pair of these.
Yeah.
If you have some approved glasses, you can actually see the sun is amazing.
I'm
it's
gonna
like
look up with my...
It's not normal.
I
But
know.
this-
It's not normal,
Yeah.
you guys. I'm going to look up with my approved binoculars.
Right.
And the truth is, oh my gosh, it looks like a crescent moon, but
It
it's
looks
a
like a moon,
crescent
right?
sun.
The sun looks like the moon right now.
And
It's
I'm
really
actually
cool.
a little bit cold. Like, have you noticed it's gotten cooler outside?
Yes, it has definitely gotten cooler.
I think I'm going to be
And
pretty
it's
cold
getting a
during
little,
totality.
the darkness has gotten a little bit darker. It's kind of gray.
I actually noticed that too. The camera
Yeah.
guys here have had to change their iris
settings,
in order,
right.
yeah, because even on the telescope, you can
Right.
notice that it was getting darker and darker, and they have to open up that iris a little bit.
That's right.
That's crazy. That's really cool.
Well, how do people send us their questions?
So they can send us their questions at National Geographic's Facebook page.
Okay.
And they can also send us questions on Twitter using the hashtag NatGeoEclipse.
Okay.
Yeah, so we've got so many cool ones. Okay, I've got one here from Charlotte T.U. Charlotte T.U., I hope I'm pronouncing your name right. And Charlotte asks, when was the last time that this happened? Charlotte, that's a more complicated question than you might know. I think the easiest answer to that question is that the last time that a solar eclipse that had totality, a total solar eclipse happened in the continental United States was in 1979.
That's right.
And so
Before you were born.
Yeah, for many of us watching today,
Right.
that was before we were born. And even for many people who were born then, who didn't get a chance to see it, right? This is their first opportunity, which is incredible.
It is. This is my first time ever seeing it, and there's millions or tens of millions of people. This will be their first time ever, and maybe only time ever to experience this.
And if you think about it, in 1979, there were no live streams.
Right.
So for a lot of people, this is the first time that even if they're not in totality, they've been able to tune in with us and experience this once-in-a-lifetime event.
I've heard this is going to be the most photographed event in human history, so we'll see if that's true or not, but everybody seems to be talking about it.
It's true. We were talking this morning about, is this going to be the biggest astronomical event? Is this going to be the most photographed event at all? And I was like, no, but the Mars rover, during the Mars rover landing, it was awesome. And he was like, Cara, we're nerds. We thought it was awesome.
Yeah. Even if you're not interested in science and have no idea, you can't miss this. If you're in the path of totality and you're awake, you're going to notice that the sun disappeared for a few minutes.
Absolutely. And the truth of the matter is, we can get really heady with the science, and I think we will. After totality, we're getting so close, so I don't want to start a crazy conversation, but after totality, I'd love to talk a little bit about general relativity. I'd love to talk about Einstein and about some of the incredible predictions that were actually proven by being able to observe a total solar eclipse. But there's a big spectrum. If you're viewing a total solar eclipse, you can really appreciate the deep, incredible telling science that's happening, but you can also think of it just this simply. We're here, there's a thing in front of a thing. That's all that's happening during a total solar eclipse. The moon is here, the sun is there, the moon is blocking the sun. They happen to align in such a way that to our own eyes, they look like they're the same size.
It's a shadow.
It's a shadow. It's just a big shadow. And the cone, that central part of the shadow, is called the umbra. We are slowly going to be within that umbra. Right now we are in the penumbra, which is the shadow that's around it, where most of the U.S. is going to be. You can hear people squealing in the background. Our mics probably didn't pick that up.
It's starting to get dark, and people are starting to scream.
To freak out a little. And here's the thing. If you read a lot about eclipses and the personal experiences that people have had when viewing eclipses, their responses really vary. For
Right.
some people, this is a religious experience.
Right.
For others, it's just a really cool sciencey thing that they get to geek out about. And for yet others, people actually get scared, you know?
Well, imagine if you didn't know this, if you couldn't predict that it was coming hundreds of years ago or thousands of years ago. You would have no idea. People made up mythology to explain dragons eating the sun and that kind of thing. And so unless you know it's coming, it could really be frightening.
And for some people, even knowing it's coming, it's you get that cognitive disconnect.
Yeah.
It's like, we know it's coming,
Right.
but I don't think we really are prepared. I don't
Right.
think anybody can be truly prepared. I'm shivering.
It-
It's
it-
cold out
like,
here.
It is getting actually pretty
It's
cold right
getting
now.
really cold.
Yeah,
I'm
it
like,
is.
why am I wearing a tank top? We are getting really, really close. It's 10:11, you
Right.
guys. So that means that we have only 7 minutes, 8 minutes, 7.5 until totality.
It's coming up.
And I don't know. I mean, I know what to expect in my mind, but emotionally, I'm not sure how prepared I'm going to be for this. I may cry. I just have to warn you. And I won't be able to touch up my makeup. So you may have a raccoon host during the rest of this live stream, which is fine. That's fine, right?
It's okay.
Okay, so we've got a Twitter photo here. And this is a nice panoramic that some people took while they were hanging out. Oh my goodness.
beautiful.
It's so stunning. And of
Yeah.
course the sun is still high in the sky there, but soon it will be completely darkened
Right.
by the eclipse, which is just incredible. Can we check in on the live stream again, you guys? Because I want to see how close we really are. Is that
Well,
not stunning?
That totality is already happening over the Pacific Ocean.
Oh, you're right.
It's racing at us at 1,700 miles an hour.
It's
shadow-
racing at us
the
right
shadow's
now.
flying,
And
yeah.
of course, it's 10:12 a.m. where we are here. And I want to just make sure it's 10:11 according to my iPhone. And that's where my solar timer is. So it's 10:11 right here. I'm getting texts from friends who are like, I can see you on the stream.
You're on TV.
And that means that we are, getting close to the countdown. That second contact is at 10:19 and 44 seconds, if we're going to be.
And I can remember
or 44
10:19.
fractions, because it's my birthday.
Exactly.
Everybody in America now knows when my birthday is. It's just turned to 10:12. So guys, we're getting really close. And what I'd like to do is, as soon as totality is about to hit, I'm going to do a little countdown. I'm probably going to stand up from my chair and I'm going to just look up in awe. I know that, Terry, you're going to try and get some really beautiful
I am.
photographs. Let's talk about some of the things we might see during totality.
Well, the first thing, you don't want to look really until it's actually totality, because even at 99% covered, the sun can still be dangerous. So don't actually stare at it until it's actually fully eclipsed. But in the seconds immediately before the moon covers the sun, there are two things called diamond ring phenomenon and Bailey's beads. And the diamond ring is called that because it looks like a diamond ring. You'll see an orange glow around the moon. And then when there's still a little bit of sun up, it's a really bright white thing. So it looks like a golden diamond ring with a big white diamond itself.
So it's kind of like when we're basically starting totality, but it's just off kilter. It's a tiny
Just
bit.
before the totality, you get the diamond ring. And then as the moon passes in front of the sun, the moon is not a perfectly round object. There's craters, and so there's a bunch of divots on the moon. And as the sun's light kind of filters and flows through those craters, it makes an uneven shape. So if you looked at the shadow, it's almost like a hexagon or a polygon on the Earth. It's not a round thing. And so the moon's craters create these things called Bailey's beads, and they only last for fractions of a second or maybe a second or two. So millions of people will have their cameras set on high speed, click, 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 firing off their pictures, trying to get that perfect Bailey's bead picture.
Oh, and here's an important point. If you are trying to do some astrophotography, or some solar photography, I should say, turn off your flash. Make sure
true.
your flash is off. Otherwise, you're going to be really not happy with the way your photos
Your
turned
flash
out.
will not light up the moon.
No,
That's
it
true.
will not.
Yeah.
No, it will not. So looking for that diamond ring phenomenon, looking for those Bailey's beads. I've also heard about an incredible phenomenon that are called shadow bands. And it doesn't always happen, but sometimes you see this banding on the ground. And scientists still don't fully know what causes it, but they look like snakes. And there have been historical reports of them being so vivid that children will try to catch them, which is just incredible. I can see, oh, look at this stunning photo that was taken.
That's gorgeous.
Gosh, no, it's not. Oh, my director just told me that's live. That's not
us.
a stunning photo. That's actually us right now. Isn't it funny? The sun looks so strange.
It is a weird pattern.
Yeah,
it is a weird
seriously.
pattern.
That pattern actually reminds me of this beautiful geodesic dome
does.
that we have behind us here. This was built for 2 lucky winners, and it was built by Airbnb. And so, in conjunction with National Geographic, there was a competition where 2 lucky winners got to spend the night in this geodesic dome, and they got to do some nighttime viewing with a National Geographic photographer and an astronomer. And now they are up in an airplane, you guys, chasing the eclipse, trying to get in some of those first images of totality. I can't even believe it. Can you see that it's gotten dark outside?
It has gotten dark and cold.
It's incredible.
Yes.
I know, I'm shivering a little bit.
Yes.
It's gotten dark and cold, and you can kind of tell even from this wide shot, the sun is still gleaming from behind the moon. It's bright enough that even that sliver is giving you all of those lovely rays, but look at the telescope here.
Yeah,
we are
barely.
literally 3 minutes away from totality.
Yeah, it is
we are
almost
so
covered up.
incredibly close.
Yeah.
I think we're at the point where I kind of want to stand up.
There come
and
the screams.
People are screaming. You can hear them in the background. Prepare for shadow band observation, guys. We are getting so close that we're gonna have a countdown in just a minute. And I'm gonna stand up and actually look. So I might be turning my back to you a little bit if you come back to see, but oh my gosh, Terry, you have to see this. The sun looks like a little fingernail.
That's amazing.
You guys, this is incredible. It's just incredible. It's still bright enough that it's lighting up Earth where we are, but it's starting to look a little bit more like dusk.
Right.
You know what
it's
I mean?
definitely
It's definitely
darker here.
Feels like the
Yeah.
sun is setting, but the sun's high up in the sky.
It's gray. To me, it looks gray. It doesn't look like normal. Like
No.
dusk is kind of orange and pink. It's not like that. It's more of a
No, we're not
grayish
getting
color.
that
Yeah.
beautiful because, you know, usually the reason that dusk is so pink is that the sun is setting low on the horizon and you
Lots
get
of atmosphere.
atmosphere in
Yes.
the way, and atmosphere turns things kind of pinkish orange.
It does.
And since the sun is high in the sky, we're seeing it through the typical atmosphere.
Right. You don't have the refraction that you get through the. So normally only red light makes it through to us at dusk, but right now all the light. So it's a weird. This is definitely
It's a really
a
weird
weirdly
color
colored
outside.
dusk. Yes.
It's spooky. I mean, there's like a Halloween vibe going on. And I know that you guys can't see it because all of the cameras right now are trained on Terry and myself,
Right.
or on the wide view, or on the sun itself.
telescope, yeah.
But all of the crew, everybody who is here with us for this incredible event, the Nat Geo guys, the Airbnb guys back here, everybody has their sun protection on. They're looking up, and off in the distance you can hear people hooting and hollering because
I can see a lot of smiles too,
It's
and a lot of
crazy.
awe and amazement. Yeah,
I'm
this
kind
is
of
amazing.
freaking out.
Yeah.
I'm going to be honest. I'm kind of freaking out. It is
It's almost there.
10:17 local time. We are 2 minutes away from totality right now, and we are so close. Look at that live stream. You can barely see the sun peeking out from behind the moon. It looks like a tiny little crescent, and it's like the opposite of what we would generally see. Oh my gosh, people are howling at the moon. We have some lycanthropy that's happening out there. Vocabulary word for you. Some werewolves are very excited about what's happening. The moon is winning, Terry.
The Team Moon is winning right
Team
now.
Moon. Who's on Team Moon? I think I'm joining Team Moon for sure. Although, if it were like this all the time, there would be no life on Earth. Let's be honest. We
That's
wouldn't
true.
be able to survive. It's so dark outside. Can you guys see this? This is crazy.
You need a jacket.
I know, I'm so cold. Terry's gonna let me wear his NASA jacket. I'm freaking out. I'm freaking out. Okay, this is the best day of my life officially. I
Okay,
get to see
we need to have a countdown
a
here.
total solar eclipse. And
30 seconds.
Okay,
Less
it
than a
is
minute?
10:18
Okay.
local time. So we are not quite to countdown, but my app is actually telling me prepare for second contact, prepare for second contact, which means that we are super, super, super close. I'm going to keep all of my viewing equipment really close by. I'm looking up with my solar binoculars. It's amazing. It's just incredible. You know what? I'm actually going to move over to my solar glasses so
Yeah.
that I no longer have to hold anything in my hands.
There's just a little bit of sun left.
Just a little. It's getting
It's not
really,
even a crescent, it's just a
getting
short
really dark
line.
outside.
Right.
Oh my goodness. We're starting to even see totality. Look,
Yeah.
there is a diamond ring happening right now.
Wow.
There is a diamond ring happening, and we're not even quite at. Nope, we're there. We're in totality. Yeah, guys, we're there. We're in totality. We're in the diamond ring right now. And as that diamond ring starts to fade, we're here. Here come the Bailey beads. Now we can look at it. Oh my God.
There it is. Wow.
You can see the stars.
You can see the planets.
Oh my God. You guys, I'm actually crying. This is the most incredible thing I've ever seen in my entire life. So you can see the sun's corona.
Yes, that is amazing.
It's massive from behind, and we get to experience this for a full minute and a half. I'm just gonna soak it in.
Look at the planets. You can actually see.
Oh my God.
I know, that is incredible. This is amazing.
Oh my God.
You can zoom in. Wow.
Terry's letting me look at it through his zoom lens on his camera. I'm losing my mind.
This is unbelievable. There's Jupiter.
It's dark outside. It's
There's
nighttime.
a little red dot on the right side. I wonder if that's
Mars?
the light.
Yeah, it's hard to say. Oh no, yeah, that might be a Bailey's bead coming through.
Yes,
And-
around the moon.
And here you go. I'll give you this back.
Wow.
Another thing that's an incredible phenomenon is that you have a 360-degree sunset right now. If you look all the way around you, you still see the warmth of the sun.
Right.
This is something you'd never, ever see on Earth except during a total solar eclipse.
That is right. There's not just one.
Guys, there's a hole in the sky.
I know.
And it looks like we're just coming out of totality. We're back into that diamond ring now. So I have to put on my eye protection. It's creeping back through.
Unbelievable.
Wow, you guys,
That
look
happened
at that live
fast.
stream. That right there is the diamond ring phenomenon we were talking about. We're coming out of third contact right now. I am so glad it's so dark that you can't see the
Look at the
tears
mountains.
coming down
I know,
my
this is
face.
amazing. Look at the mountains there. That is so awesome.
It's just incredible.
There's shadows on the, there's a man
There's a guy tightrope
Tightrope
walking.
walking.
Guys, we're actually in
Yeah.
front of a really famous rock climbing area, and there are people up on the ridge. They climb the rock to be able to enjoy the total solar eclipse. There's even somebody who's tightrope walking along this monkey head rock in order to see it in all its glory. Oh my gosh. So now we are in third contact officially. We're on the other side of the solar. There's our rock climbers. You can see two of them on the rocks, and then you can see one on the tightrope. He enjoyed the solar eclipse from the tightrope, and can you see the crowd underneath cheering him on? Okay, we're talking about having a once-in-a-lifetime experience. What about that guy? Congratulations to him for pulling that off. That is incredible. Just incredible.
That was amazing.
And it's starting to warm up again. It's starting to get bright again. Guys, we are here. If you're just tuning in, you just missed totality.
Wow.
We are here live on Facebook, on YouTube, and on Periscope with National Geographic and Airbnb celebrating this momentous once-in-a-lifetime experience. I mean, you can probably still hear that my voice is shaking. This was... I knew I wasn't going to be prepared for this. I knew I wasn't going to be prepared for this. And I'm still a little shaken up. I'm still crying. Also,
We need makeup.
yeah, we need makeup. No. Also, Terry Virts, former astronaut, former space shuttle commander, has allowed me to wear his astronaut jacket. So this is a doubly exciting day for me.
So we need protection again.
Yeah, we now
Yes.
have our sun protection out because we are fully into third contact. What that means is that totality has passed, the moon has passed in front of the sun, and we are now back into a partial eclipse. And it's a tiny little sliver. You can see it here on our live feed from the telescope. We would love for you, if you were in this part of the country and you also saw totality, we would love for you to send us your photos using the hashtag #NatGeoEclipse. Send us your comments on Facebook as well. I'd love to read some of those live on air and maybe answer a few more of your questions. I'm calming down a little bit. How about you?
There were so many things that just happened. And it happened like that. There's no way that was a minute and a half.
fast. I
That was like
know.
5 seconds.
It's
that
just
happened
too
so fast.
I wish that we had that experience where time stood still
Yes.
instead of accelerating.
So during space shuttle launches, we would tell people just stand back and enjoy it. And taking pictures is fun. And if you're east of where we are right now and you're gonna be in totality, I recommend take your pictures and then put the camera down and just enjoy it. That was
Yeah.
amazing, seeing the corona.
Yeah.
Like you could see the sun's atmosphere.
Guys, Here's the
that
thing.
was incredible.
The sun's not moving too much during totality. So if
Right.
you put your camera on a tripod and you set it to auto take and let it do the work for you,
Yeah.
I would just stand back and experience it. So let's recap a few of the things that
Yeah.
we saw.
That was incredible.
Whew. We saw the diamond ring phenomenon.
We did.
I think we saw some of those Bailey's beads. I mean, they weren't too strong.
I'll
but
have
I
to look
think-
at my
Yeah,
pictures,
we
yeah.
gotta look through the pictures
Yeah.
again. It was so fast. Day became night,
Yes.
which was very strange. The birds went crazy.
People were screaming,
People were screaming.
crying.
The corona of the sun was incredible.
It was huge.
It was
Yeah,
massive.
that was amazing.
You
Yeah.
could see these plumes of gas
Yeah.
just shooting off. And one thing that a lot of people don't realize, I didn't realize it, the corona of the sun is like way freaking hotter than the sun
Yes,
itself.
right.
Because of some sort of magnetic phenomenon forces
Yeah.
this to be superheated. And you could see banding. You could see the beauty of the banding with your naked eye during
Right.
totality. Another
You could see
thing,
planets.
You could see planets
Yeah.
in the sky. You guys, day became night. You could see the stars and the planets. And another thing that you see, and if you haven't yet hit totality, prepare yourself for this and don't forget to look. Do a 360 where you are. There's a 360-degree sunrise, sunset. I
Right.
don't know what to call it, but you still see the glow of the sun along the horizon.
Right.
It's
Normally sunset, there's just, red and pink there.
on one side.
But it was like all around us. Yeah.
Stunning,
It was amazing.
you guys, absolutely stunning. Okay, I have all of my stuff in my chair. I'm going to reset a little bit because I want to see if any of you have reached out and sent us your comments and your
Let's look.
questions. And oh, look at the beautiful geodome right now, you guys. It's so pretty. We're so lucky to be here in Central Oregon with National Geographic, with Airbnb, with that stunning geodome behind us. And I got to keep my eclipse glasses close by because I'm not done watching
No.
quite yet. But let's see if, yeah, okay, we've got the telescope view in front of us too. And I'm just going to check and see if there are any new, oh, we've got some, no, we've got those photos. No, I want to see some questions. Oh, this is an interesting question. All right. We've got a question here from somebody who doesn't have a username, which is fine. Is there a chance in the future that eclipses will be caused by other planets? And that's a question from Kazakhstan. Will eclipses be caused by other planets?
That's a great question. There are eclipses that happen all the time around the solar system because many planets have moons. The problem with planets is they're so far away from other planets that the shadow that they form is so small it would never make it to another planet. And if they ever did, it would probably be really bad here on Earth. If Jupiter were close enough to cast a shadow,
yeah,
we
we
would
still
have
wouldn't be
bigger
here at
we would
that
have bigger
point.
problems.
That's
Yeah.
true. So the planets are a little too far away to completely obscure the sun, but there is an incredible phenomenon called the transit of Venus.
Yes, I actually saw that. I think it was 2004 using a pinhole camera. I took the piece of cardboard, made a little pinhole, and you could see it on a piece of paper.
Yeah, you can actually see Venus transiting across the surface of
Right.
the sun. Scientists use those measurements that they take during the transit to
Right.
learn all sorts of things about our solar system, but it's teeny tiny.
Right.
It actually looks like, have you guys seen these incredible photos of the space station
Yes.
traveling across the surface of the sun? It looks a lot
Yes.
like that.
So we had one of the favorite things I did in space was film an IMAX movie called Beautiful Planet, and our director of photography, James Nyhouse, actually came out to California, had a special camera, and took a picture of me flying in front of the sun on board the space station. It was like 1,000 frames a second, a really specialized camera.
Whoa.
But that's pretty cool. So if you were on Mars, you could get a transit of the Earth. You
Yeah.
could see the Earth move in front of the sun, but that would be pretty rare and not that common of a thing to see.
But I did read that on Mars, you have a solar eclipse it's almost every day. Like,
Yeah.
it's really common because the thing is, Mars's moons are tiny,
Yeah,
But they're-
Phobos and Deimos
but
are
they're really close to
they're
Mars.
small, and because they're so small, they can be close to Mars to stay in orbit. And so there's a small shadow going across the surface all the time.
Yeah, so even though we won't have any solar eclipses that are caused by other planets, there are solar eclipses on other planets caused by their own moons quite often.
It is. So when we finally send people to Mars, we won't have to have special National Geographic coverage, live coverage of the eclipse, because it's going to happen so often.
We'll just all get to see it with our
It won't be
naked
a big deal.
eyes.
Yeah.
Oh my gosh, I love it so much. Oh, we've got another question here. This one is from Stacy Renee, and she asks, actually she says, my students are wondering, hi students, if it's cloudy out, does that affect the temperature drop? #NatGeoEclipse.
So it wouldn't be as severe or
Yeah.
significant, but I still think there would be a temperature drop just because the sun's disappearing. That's a great question.
That's
I've
a
never
really good
experienced
question.
it. Yeah.
I bet you it really depends on how heavy the cloud cover is. You
Right.
know how sometimes when the cloud cover is so incredibly thick, you just don't get much of the sun coming
Right.
through. It's already kind of dark outside on a stormy day, and it's
Right.
cold anyway. I bet you in that case it wouldn't have that
Right.
much of an effect.
And where we are in the high desert of eastern Oregon, the temperature is completely dependent on the sun. This morning it was cold, and as the sun came up, it warmed up. But if you're in a place like Houston, where I'm from, it doesn't matter where the sun is, it's hot all the time.
Yeah,
right?
that's
so
true.
So it kind of depends on where you are and how much of your temperature depends on the sun or not.
Yeah, it was dramatic here in Central Oregon when the sun was blocked by the moon during totality. I was freezing. I actually got to borrow
Yeah.
Terry's astronaut jacket. He let me borrow it. You can have this back now. If you're not careful, I will walk off with that. So yeah, Stacy, I hope that answered your question. You know what, Terry? I'm reminded of some parallels between the total solar eclipse and some of the experiences that you've been telling me about being there during shuttle launches.
Right. Yeah, that was interesting to talk about the day turning into night, which is what we just experienced. By the way, I'm still kind of on a little bit of a rush. That
I know,
was
I'm
amazing.
shaking.
But at a shuttle launch, when I launched, both my launches were at 4 in the morning, which is a great time. I highly recommend that if you ever get a chance to go into space. 4 in the morning is
Oh,
great.
good to know. I'll keep that. Yeah, 4 in the
But-
morning, go to space.
On my first launch, there was a thin deck of clouds. And when the shuttle engines lit up and the solid rocket boosters, the big white rockets lit up, nighttime turned into day. And for hundreds or tens or hundreds of miles, all of a sudden it was daytime. And I love that people post their home movies on YouTube, and you can Google STS-130 launch, and people are screaming and cheering because nighttime turned into day.
And so,
And
but
here we are at
nighttime-
the eclipse.
Yeah.
Daytime turned into night, and people were screaming and cheering and getting goosebumps. It's a weird parallel, but it was really similar.
But like the opposite.
Yeah.
And then
Right.
nighttime of course turned to day in quotes because it wasn't from the sun, it was from the bright rockets, right?
Especially because we had clouds, so it reflected, and
Yeah.
it was amazing.
Oh, that's incredible.
Yeah.
And of course, this phenomenon of sort of a hole being ripped in the sky.
Yes.
You know, for a lot of people, and for me too, when I was watching that eclipse, it looked like there was a hole
It
in
did.
the sun.
With the sun's corona, it looked like somebody had shot a hole.
Because the moon doesn't look like the moon. It's
no.
just a shadow.
Yes. You couldn't tell that was the moon. It was just a hole in the sun.
And of course, when the shuttle launches, it sounds like there's a
Yeah.
hole being ripped in the sky.
The closest you could be was about 3.5, 4 miles away.
Really?
And so it takes, 10 or tens of seconds for the sound to get there, because the speed of sound is about 1,000 feet per second. But when it finally gets there, there's this ripping and this violent shaking in your chest. You could feel it. And it sounds like the sky is being ripped in half. And just seeing the eclipse, it was a similar, of different reasons, obviously, but it was a similar emotional experience.
Just stunning.
It was amazing.
You guys, I'm still shaking. I can't even deal. All right, so I think we have an Instagram photo here of some cameras. Can we pull that up? Some cameras that were set up at Jackson Hole, where people were preparing to watch the eclipse. I think we can pull that up. If not, it's not a big deal. Maybe we'll be able to get to that. Oh, there we go. I love this. Guys, I love how this event brings so many amateur astronomers, so many everyday people who are getting excited about science together in order to experience this monumentous occasion.
This is something we can all enjoy and experience together. It doesn't matter if you're an amateur astronomer or a scientist or have no idea about what a moon is to begin with. It's something that brings us all together, which is pretty amazing.
Yeah, absolutely. Oh my goodness, you
Here it
guys, we
comes.
are about to break something huge. We are getting the first photos of our crew who is up in the plane taking a picture of the solar eclipse.
Wow. It looks
So
like they're in
they flew
space.
back
Yeah.
over the Pacific in order to get it before it came to us. And it does. It looks like
they're in space. Yeah.
So you guys can see this 360 phenomenon I'm talking about, where at the horizon, you see the glow of the sun, but up in the sky, it's utter
Yeah,
darkness.
it's blackness. That's-
40,000 feet right there in the air where they took this photo.
Yeah.
What an odd perspective.
That's what it looks like from space, especially that blue band. You can always see, not always, but at the right sunlighting, you can see that blue band. And if it were not for the airplane wing, you could tell me that was a picture from the space station, and I'd believe it.
That is incredible. And what an incredible contest. These two lucky winners, you guys, won a contest that was sponsored by Airbnb and National Geographic. And you can see in the background right here, this beautiful geodesic dome. It's all lit up by the sun, by the partial eclipse of the sun. So they got to spend the night in this geodesic dome. They got to do some night viewing of the sky with a Nat Geo photographer, with an astronomer, and then this morning they went up in a private plane and they chased the eclipse. So let's talk a little bit about that, chasing the eclipse.
Right.
Obviously they can't catch it, because how fast does the eclipse move?
It's going about 1,700 miles an hour.
Yeah, I don't think we have airplanes that go that fast,
yeah,
do we?
they're in a Gulf Stream right now, so it's probably going about 500 miles an hour. Although we were reading last night in 1972, the Concorde, which was a supersonic passenger airplane that went twice the speed of sound, chased an eclipse across Africa, and they got over 70 minutes of totality.
70 minutes. And of course, NASA just right now is actually chasing it. And what kind of planes?
It's called a WB-57. It's an old Air Force airplane from the 1950s and 60s that NASA has repurposed for science. You can put all different kinds of instruments that look at Earth or look at the sky. And right now they have special instruments that are looking at the telescope. And the advantage of being in an airplane is you can fly to the east and not completely keep up with it, but spend more time in the shadow than we just had 5 seconds in the shadow.
I know, it feels like we only had 5 seconds.
Yeah.
We had a minute and a half of totality. And here's where we are right now in third contact. So we're in a partial eclipse on the other side of totality. We have already seen the total eclipse. So we had a minute and a half. Our contest winners up in the plane, I think, are getting about 4 minutes, maybe 3.5, maybe 4.
They were saying only an extra 20 or 30 seconds.
Well, that's a bummer. So anywhere on the ground in the United States, I'd take it too. Anywhere on the ground in the United States, you're going to get, if you're in the path of totality, anywhere from a couple seconds to just over 2 minutes.
Right.
So they got a leg up on anybody on the ground, but these NASA planes are getting close to 7 minutes.
They'll get multiple minutes, which is amazing.
Amazing.
Right.
Oh my gosh. Can I see that picture from the plane again? I would love to see. I'm dying.
That's amazing.
This is incredible, incredible. And Terry, are you going to post some of your photos after the stream so that we can get a look at them?
I am. I'm trying to do it now. We'll see how the Wi-Fi connectivity is going for my camera. So
and you're at Astro Terry.
Astro Terry on Twitter and Astro_Terry on Instagram.
Great. And I'm going to be also tweeting and Facebooking a lot of eclipse data throughout the day. I'm at Cara Santa Maria on Twitter, and I'm at facebook.com/ScienceCara. But of course, this amazing experience that we're doing, that we're having today, this stream that's hosted, it's going to be, or it is right now, on National Geographic's Facebook page. So reach out on National Geographic, tell us what's going on in your neck of the woods, and you can also reach out on Twitter using the hashtag #NatGeoEclipse. We are here with National Geographic and Airbnb, and we are so lucky to be in such a beautiful part of the country, experiencing the awe and wonder that is this once-in-a-lifetime event.
I've never experienced anything like that. That was
and you've
really
been to
powerful.
Space! You've been on space walks.
I have been, yes. But this was a unique experience. I've never experienced anything like that.
You guys, that's a quote, okay? That's a quote. I want to see that trending on Twitter right now. He's never experienced anything like this.
It's true.
It's just incredible. It's just incredible.
Yeah.
All right. I'm hoping that a few more of your comments are able to come in soon. I'm wired up with you, but of course the Wi-Fi is not incredible out here in the middle of the high desert. Let's see where we are. Are we going to be able to check in with any other of our National Geographic science writers, any of our correspondents on the ground? Okay, so we're trying to establish some connections right now with some other folks that are on the ground so that we can chat with them. I teed this up before and we didn't get a chance to talk about it. All right, we're about to bone up a little bit on general relativity.
That's right, yes, some of the science that's going on here.
Yeah.
So one of the amazing things that we just experienced when the sun disappeared, Team Moon was winning for a couple minutes, but I think Team Sun's back on the on the offensive.
Team Sun is for sure back up. I'm just going to put on my super cool eclipse shades one more time.
That's right.
And take a look. It's so weird because it's like the opposite moon.
It's like a
crescent moon that's
it's like
glowing.
a fat crescent moon.
but
It
it's
is.
the sun. It's orange. It's so
an orange,
strange.
yes. So one of the things that we saw, you could see planets. And back in 1919,
Yeah.
right soon after Mr. Einstein had decided or had come up with this general and theory of relativity, they wanted to test the hypothesis that gravity could bend the light of stars. And so during an eclipse, they were able to look at a star that was really near the sun. Normally you can't see the star because it's too bright. But during an eclipse, it blocked the sun's light so they could see where the star was, only the star was a little bit not where it should have been, and that was because the gravity from the sun was bending the light of the star. So the star didn't actually move, but where it looked to us moved because the sun was like a big lens out there that kind of bent the light. And then that just proved that Einstein was right and that relativity was true.
Yeah, and so, you know, if you think about it, prior to Einstein's really groundbreaking theory that a lot of people didn't really believe at first, people thought that gravity was a force. Like it was a physical force, an attractive force that's pulling. And we sometimes talk about it that way in a Newtonian sense in order to understand it at a more kind of elementary level. But the truth is, as Einstein posited, gravity is actually just what happens when space-time is shifted.
Gets warped.
So space-time is this fabric that's out there. They're inextricably linked. And when there are large, large objects, they physically warp the space-time around them. So he was saying, guys, if the sun goes out and we're able to see all of the stars that are really close to the sun, we should see some warping. We should take their measurements during the eclipse and be just a little bit different than how they are at night. And
but actually, beyond that, things like time change. Things like your mass changes and your size change too.
And you know
gravity,
this.
And I know this because when I was in space, I aged 7 milliseconds less than everybody else on Earth. So I'm younger than I would have otherwise been. You might have noticed.
You went back in time? Also, wait, so you're
I didn't really go back in time, but time slowed down for me.
Time slowed down for you. That's a better way to put it. So not only did time slow down for you, you grew?
I did grow, but that wasn't from relativity. That was from a lack of gravity. You know, all astronauts get taller, and I was 6 feet tall while I was in space.
But
we have a tape measure on the wall, and you could I was 6 feet tall, and then within a couple hours back on Earth, gravity was 1 again, and I was back. Yeah.
You must feel so heavy when you first land.
You feel very heavy. After my first flight, I was sitting there getting the space shuttle powered off. It'd probably been 30 minutes. Finally, it was shut down, and it was time for me to get out. And a fellow astronaut came in, and I reached in my helmet, and I was like, "Oh, be careful! This helmet weighs 500 pounds."
No, it doesn't. It's cool.
But after a day or two, you're back to normal. But the first day, you're dizzy and heavy.
So how many hours did you spend in space?
Over 7 months.
Over 7 months. Okay.
7 months times 24 times. Yeah.
You were a math major.
I was a math major.
But how many hours or minutes, I should say, did you spend on EVA doing a spacewalk?
So my spacewalks were over 19 hours. I did 3 different spacewalks. Yeah.
And of course, all of the photos that you took in space were taken from within the ISS. But you've taken how many total?
Over 300,000.
300,000, and you can see here your new book, View from Above.
That's right.
That includes not all 300,000.
Not all 300,000. I'm super excited about this book. It's a National Geographic photography book, but also with stories from space. So it's not a memoir. It's about taking a space mission and putting it in book format. And between the pictures and the stories, I think I tried to capture what it's like to be in space. Super excited, October 3rd.
October 3rd. Most of us don't have the pleasure, obviously, at least not yet, of being able to go to space. So this is a great way to be able to do it.
It's a way to share it, yeah. So many millions of people are super interested in space, and I wish they could go. And I think in the future, more people will have a chance to go. But for now, there's only been a few hundred of us that have gone. So I'm trying to share that experience.
And of course, the statistic was, until today, that 1 in 1,000 people across the world had ever experienced a total eclipse.
Right.
That it's such a rare event.
It's a rare thing.
It's rare in the sense that it doesn't pass over our heads very often.
Right.
It's not rare in the astronomical sense.
Right.
The things line up in such a way that there's an eclipse quite often.
Right.
But usually it's happening in the ocean. Usually it's happening in a place where there's not a lot of population.
Right. Or in space.
Or in space.
The moon shadow is always there somewhere.
Yeah. But here in the United States, in the continental United States, actually in all of the United States, everybody got to experience at the very least a partial eclipse, and
Right.
a fair amount of people were in the path of R. Oh my gosh,
Right.
R in the path of
Right
totality.
now.
You might be in a total eclipse right now.
It's passing over the middle of America right now.
You guys, that's insane, and I want you to tell me about it, okay? So make sure that you use the hashtag NatGeoEclipse, and there is our NatGeoEclipse. This is a live feed from our telescope right now. Oh my gosh, okay, we've got some great questions that are coming in here. Oh, okay, and here's one from Rizwan Qureshi. And Rizwan asks, when shall we expect the next full, lunar eclipse in the future, and in which part of the world? Why would you ask us a question we don't know the answer to? That's terrible.
Well, let's talk about what a lunar eclipse is versus a solar eclipse.
Yeah, that's a good idea. That's a good
So
idea.
the moon is casting a shadow right now on Wyoming, or roughly it's in the middle part of America. And that's a solar eclipse. But the Earth also casts a shadow, and right now it's just out in space somewhere. But when the moon passes on the other side of the Earth, and it goes into that Earth's shadow, that's the lunar eclipse. So it's similar idea, it's just 180 degrees out.
Oh, it's so cool.
Yeah.
That's so cool. And, you know, we talked a little bit about these Soros cycles, these cycles that are about every 18 years. And of course, Soros cycles mean that the same eclipse happens every 18 years, but it's not going to be in the same place on Earth because, of course, the Earth is rotating. So unfortunately, we only get an eclipse in the same place on Earth every 307.
Right.
375.
Yeah.
Gosh.
So the
375
geodesic
years.
dome,
Yeah.
375 years, enter the Airbnb contest,
Exactly.
and you can be here for the eclipse
We'll be
right here
here
on the same
again.
spot. Yeah.
But that Soros cycle also applies to lunar cycles. Isn't that cool?
Yeah.
So we also have that same lunar cycle that's happening about every 18 years, which I think is about 6,500 days.
Yeah.
Just in case you were
Roughly,
wondering.
plus or minus.
We have a call. Who is our call from? Who are we on the line with?
Howdy, this is Alistair Hayden calling in from Victor, Idaho.
Hi, Alistair.
Cool.
How are you?
Good. How are you guys? We just experienced totality here, so I guess we're a few minutes behind you all. And I just wanted to check in. So I'm a National Geographic explorer. I'm a geologist, and we're out here with a bunch of other geologists and astronomers and biologists, all just taking in the sights.
Oh my gosh. So Alistair, we just had totality a few minutes before you. I cried. I'm going to be honest. I think people could hear it in my voice. I couldn't hide it. Tell me about your experience.
Oh, the experience was, I mean, you hear about how awesome it is, but nothing just prepares you for it. You know, you hear about the temperature dropping, and it looks like you're wearing sunglasses. It's just so dark out. But you look around, and we had a perfectly clear sky, and so it felt like there was clouds, but there was definitely not. And we're up here on a hill overlooking the, I believe it's called Teton Valley. So we're just to the west of Teton National Park. Right here, there's lots of people today, but we could hear the people down in the valley. We heard the shouts go up across the valley as totality was happening.
Yeah.
And so it started in the west on the other side of the valley and came over to us. And, you know, our whole group, we've got 30 scientists out here, and they all whooped and hollered just as well.
Oh, incredible. We're looking at some photos that you sent in right now. You know, we could hear people. We're in a pretty remote place in Oregon right now, but we could hear people all around us.
Right,
kind
for
of
miles they were
howling and
screaming.
hooting.
Yeah.
It was such a stunning experience. Alistair, have you seen a total solar eclipse before?
So I've never seen a total one, but my parents took me out of school when I was about 7 or 8 to witness one of the partial ones, and I'll never forget that in our garage there was all these holes, and then just looking at the floor and seeing the pinhole camera projections of the eclipse, and we traced them out in chalk. And I you know, it's one of those things that just seems too crazy to be true, but we saw the same thing again today, and so this was something else.
But you saw,
And we
what you saw was, I think, like pretty, you know, a wonderful author once said that comparing a partial eclipse to a total solar eclipse is like comparing riding in an airplane to falling out of an airplane.
Yeah, that sounds about right. Yeah, the experience was just something totally different. And
So I have a
and we're
question,
so happy
Alistair.
we came out.
Oh,
yeah,
sorry,
go ahead.
it's Terry Vert. So let's do the same question. On a scale from 1 to 10, you saw partial eclipse and total. So let's say if a partial eclipse is 7, what would you say is a full eclipse? I think I know my number, but I'm curious to see what you think.
Yeah, polling everyone. Well, Are we? Is it on a scale of 10, or are we allowed to go past?
Well, yeah. For me, it was about 1 million.
Okay. Yeah, there we go. It's definitely way past off the charts there.
Yeah, that was amazing.
And so we're very excited about this one. So as a geologist, I was really excited to come out to this specific area. We put together all the great NASA data from the MODIS satellite to figure out where the least cloudy areas were. I don't know if you guys did that out in Oregon too.
We did not, but we lucked
why
out.
you headed there.
Yeah, we just lucked out here.
I'd rather be lucky than good.
Exactly.
Yes.
Yeah, so we found the spot. So there, anyone listening can go on the NASA website and download just the cloudiness data for the entire world, and it goes back 16 years. And so we looked at just the month of August, and then figured out where in the U.S. was going to be some of the least cloudy. So out here in Idaho, it's an average of about 1 or 2 cloudy days out of the entire month of August, and we wanted to optimize our chances here. And we were fortunate there's no forest fires. I've got some friends out there in Oregon, and I heard that's obscuring some views.
Absolutely.
Yeah.
We're lucky enough to be on the east side of the Cascades here, so we were able to get beautiful clear skies. But I know that for some people that are closer to the Cascades or on the west, they were dealing with some smoke from the forest fires, which is a huge bummer. And of course, there are parts of totality that are completely in cloud cover right now.
Yeah. Yeah, we'll hope that the East Coast folks who still have their totality coming up get some good views.
I would say if there's somebody watching and they're not sure and they're near totality but they're busy, they have an email they need to write or something, drop what you're doing and go experience totality. That's something that will probably never happen again. It's worth taking a few minutes and making sure you do it.
Absolutely. So, Alistair.
One of the things
go ahead.
Go ahead.
No, go ahead.
I was going to say one of the excitement doesn't just stop now. One of the things I'm excited for is NASA's also got this Discover satellite up right now, which is, I forget what it stands for, but it's a climate observatory, and it just sits there and stares at Earth, and it sends back pictures almost in real time. And so I think it takes about a day to get uploaded to somewhere that everyone can go access it. But tomorrow I'm going to go check, and we should be able to see the shadow of the moon moving across the U.S. on this almost real-time. It's like a webcam for the Earth, basically. And so tomorrow, I highly encourage everyone to go check it out. The camera is called Epic, so the pictures are going to be awesome. And it's on the Discover satellite, so everyone should check that out.
Absolutely, that's so great. And of course, you can compare that to the kinds of pictures that Terry himself took from the space station, seeing that penumbra and even the umbra actually being cast there on the Earth. Well, Alistair, thank you so much for checking in with us, and I'm so glad that you had a happy eclipse day. It was just incredible.
Yeah, well, thank you very much. I wish you guys the best for the rest of the day and all the people upcoming about to get totality.
Absolutely. May you have a happy totality. Thanks, Alistair.
Thank you very much.
Incredible. Okay, I have a great question here, you guys. This one comes in from Kathy Adams, and she asks, what about your pet's eyes or, your pet's eyes or other animals? 1,000 question marks afterward. Yeah, it's an interesting question.
Yeah.
We mentioned that chimpanzees actually often look up. I'm not sure that when a dog does freak out, because they do tend to freak out a little bit during an eclipse, it's generally not because they're looking at the eclipse itself. It's because of the darkness that comes from the eclipse.
Yeah, I think most animals will not stare at it. That's an interesting question. I've never heard studies that show lots of animals having eyesight loss, after an eclipse, but that is a great question.
Yeah, I mean, I think the animals that we should be concerned about are the great apes, who have the curiosity and the interest to go, what is going on, and actually look up.
Right.
And so hopefully they get to experience the awe of totality.
Right, and they won't really want to look until it's totality, and during that minute or two it's actually safe to look, so hopefully it's not too bad.
It's true. And I even noticed, and I think most of you will as well, the sun will tell you when you can look at it and when you can't.
Right.
It's perceptibly darker
Oh, yeah.
during totality. And when the diamond ring phenomenon happens and the sun just peeks through, it's blindingly bright. And
Right.
you have to put your solar glasses
A
on
few
then.
seconds before totality, it's too bright to look at.
Exactly.
And then all of a sudden it's not.
And then
so
all of a
you know,
sudden,
right.
totality's done before you know it,
It
guys.
only lasts a few seconds.
That's the thing I didn't realize. I mean, I'm like, oh, it's 1:25. That's a long time. That's
right.
not
It's
enough.
not. It's not enough.
It's not
And you know what's
enough.
interesting? In that 40 mile, or it depending on where you are, how wide it is, band, if you're on the edge of it, it's only a few seconds. Like we drove 10 miles and added a minute to our amount of totality.
I know, isn't that incredible?
And the 10 miles south, it's not even in totality at all. So it's a really location-dependent amount of time that you get in totality.
Do we have a map of that? I'm not sure if we do, but there is this wonderful map that, okay, but you can access this online, and of course National Geographic has published this wonderful map that shows the path of totality. It shows it going from the western portion of the United States, starting in Oregon, all the way down to the eastern portion in the Carolinas. And you can see the band of totality, but you can also see the larger bands of the penumbral shadow, the larger shadow that's cast by the partial eclipse. And you can determine where you live within that and how much of the eclipse you're going to experience. And even if you're not within totality, I do recommend that you go outside and you look at what's going on. And remember, the partial eclipse lasts a long time. We're still within it right now. Can we get a look at that live feed of the sun? It's just stunning. You guys, I know it looks like a hole in the sky, but that's the moon. Isn't it crazy because it's backlit?
It's just surreal.
You can't tell that it's the moon.
No. It's a hole. It looks like just a hole in the,
it looks like
in the sun.
A hole in the sky.
Team Sun is winning, though. It's on a
Team
comeback.
Sun is absolutely
yes.
winning. All right, so we are lucky enough to be dialed in now to a Nat Geo Science editor, Victoria Jagger. She's dialing in from Sweetwater, Tennessee. Hey, Victoria.
Hello, how's it going?
It's going great. Okay.
Amazing.
Where are you guys so far in the journey? You have not hit totality yet.
We have not hit totality, but we've got an absolutely gorgeous partial going on out here right now. That started just after 1 o'clock on Eastern time.
Just after 1 o'clock. Okay, so we're still in our partial, but we're on the other half of the partial. We're after third contact because we saw totality. And let me tell you, my life is different.
Hey, no spoilers.
I know spoilers. I do. Let me give you a little bit of advice, and I've been giving this to the people on the stream as well. Don't just look at the sun during totality.
Yes.
Take the time to look around you, look at the horizon, look at other people's faces, look at the ground. There are so many fascinating phenomena that occur during totality that you want to experience the whole of it.
Oh, absolutely. We are fortunate enough to be sitting on some absolutely gorgeous rolling hills on the grounds of a vineyard here in Tennessee. And the word on the street from a NASA astronomer who happens to be here too is that if we stand in the right spot, we'll have enough height to see the moon's shadow actually roll across the field.
That's insane.
Wow.
Wow. Oh, that's a perspective not many people will get.
Yeah, I wonder if these mountain climbers could see that, because they were cheering a few seconds before we saw anything. So I wonder if they could see the shadow
They may
coming.
have.
Yeah.
Yeah, we were lucky enough. We're here in front of a beautiful rock face. That's a pretty famous rock climbing location in Central Oregon. You can see it here in the background. And there are actually people who climbed the rock and were up on the ridge. Even somebody who tightrope walked across between two rocks and actually experienced totality from a tightrope. Can you believe that?
He has bragging rights.
Yeah.
Yeah.
Whoa, yeah.
So, Victoria,
I don't know if I'd be brave enough for that.
I absolutely wouldn't.
No.
It gets too dark. I wouldn't be able to see what was going on. So, Victoria, you, of course, are you're the science editor for National Geographic, right?
Correct.
And you have been able to oversee a lot of incredible stories that have been published throughout the last hours, days, and weeks about the eclipse. As you were doing your research and as you were reading all of the incredible things that were written both by yourself and by a lot of the incredible journalists that you work with, what did you come across that surprised you? What is your most exciting discovery about the total solar eclipse?
It's going to sound a little cheesy, but I think one of the things that really surprised me and still surprises me even today is just how excited and how curious people are getting about what's happening and why it's happening and how it works. I've seen some really amazing questions that I guess because I'm so steeped in it at this stage of my life, it didn't even occur to me to ask, but they're really smart questions. Somebody asked me very early in the process, for instance, if the sun rises in the east and sets in the west, why is the eclipse going from west to east?
Huh.
Yeah, I had the same question when I
Okay,
was,
Victoria,
yeah,
please tell us, what is the answer to that question?
Well, it starts with, of course, from our perspective, the sun is still moving from east to west, but the difference being that we've got the moon getting in between us, and when we experience the eclipse, we're in the moon's shadow. And because of the rotation direction of the Earth and the orbital path of the moon, that sort of like, it's as if the moon is beaming a dot of dark onto the planet.
Yeah.
And that dot of dark is moving from west to east.
Yeah, because the sun's location really doesn't change too much during the eclipse, does it?
It's doing its normal thing.
Yeah.
But for the most part, it's just rising high in the sky.
Absolutely.
Depending on where you are.
I am so glad this happened with the sun really high in the sky. You know what I mean? I'm so glad that where it was, or is for those who are experiencing it right now, is pretty close to the zenith, so you can see it no matter where you are. The hills don't obscure it, the mountains don't obscure it. That's very, very lucky.
It made the difference more dramatic too. It went from like middle of the day to middle of the night.
Absolutely.
It was a more dramatic
But if this
thing.
eclipse were happening just after dawn or just before dusk, it may not have been as dramatic. But because it was full sun, middle of the day, it was just stunning. Okay, so Victoria, Terry and I, we've talked about the alignment of the sun and the moon and the planet during the eclipse. We've talked a little bit about Soros.
What's that called?
I can say this. Syzygy. Right? Did I get that right? Okay, it's a great Scrabble word.
Beautiful.
Yes,
beautiful.
Great, but apparently the trick is, for the extra Y, you have to use a blank. There aren't enough Ys. Little tidbit. So we've been talking about that. We've been talking a little bit about relativity and about Einstein's discoveries. During the 1919 eclipse, we talked about how the last eclipse here in the continental U.S. was in 1979. A little bit about the frequency of the eclipse. What have we left out? What's something like some cool science information about the eclipse that we haven't gotten into?
Have you talked much yet about how nature responds to solar eclipses?
We got to talk about that, and we were so lucky that we did. We heard some crazy bird activity while we were here, and we had, of course,
Crazy
yeah, we did have some crazy people howling at the moon. But also I think Andrew spoke a little bit about, I asked him what was the most interesting thing he had written about, and he said the top 10 crazy things that animals do. What else? What else is like a cool science thing that people who maybe are out there looking at the eclipse and just marveling at the awe of it don't really realize is happening?
Wow, that's an interesting question. I guess, if you've already talked a lot about historic eclipses, have you talked much about the sort of prediction cycles that they go through?
No. How does this work?
So we've been predicting eclipses for a very, very, very long time, right? Like the Babylonians have records of being able to predict lunar eclipses, and the ancient Greeks were predicting solar eclipses. An eclipse, because of the orbital dynamics, it's literally as predictable as the sunrise. We know down to like minutes to seconds now when they're going to happen. So we're able to look back at historic eclipses that maybe aren't in the record and say almost certainly one happened on this day. And then we're able to project forward and say for the next 8,000 years, we know exactly what day, what time, what the path is going to be across the planet. So if you get really into eclipses and you really love this one and want to see more, it's going to be made very easy for you.
Oh, that's incredible. And of course, Terry pointed out that in 600 million years, we won't have any more because the moon is slowly shimming away from the Earth.
Correct.
What a bummer.
So
what about 600 million years? That's so soon.
See them all you can.
Exactly. So, hey, Victoria.
By then we'll have gone out into space and maybe we can see eclipses from other planets.
That's true. I would think that by then, either we won't be here or we'll be somewhere else. So hopefully that's the situation. So, Victoria, have you seen a total solar eclipse before?
This is my absolute first time.
Isn't it so incredible how almost everyone we talk to, this is their first time? And for many of us, it may be our last time ever. I mean, it's such an important experience. So Terry was just urging individuals before, and I think it bears repeating. If you're in the middle of your workday, if you're running errands, if you have that one email that you're trying to answer, just put it down. Just put it down and go outside.
Yep.
If there ever were a day to go outside and look up with proper eye protection, today would be the day to do it.
Yes, please.
Well, Victoria, thank you so much for checking in with us. How much longer until your totality?
Well, it's about just after 2 o'clock here in Tennessee, and totality starts for us right around 2:30ish, a little after 2:30.
So you only have about 30 minutes to prepare. Let me tell you, the whole time you're preparing, you're like, okay, we got time. Here comes the countdown. I completely missed our countdown, and then it was over before I knew it. Like, you think you're prepared, but when it happens, it goes by way faster than you would like it to. So I wish you the happiest of eclipsing. You and everybody who's on the East Coast right now, I really hope you enjoy this momentous occasion.
Oh, thank you so much, and thanks for dialing me in. This has been a lot of fun.
Absolutely, and thank you for all of the incredible work that you've been doing. Guys, go to National Geographic right now and read all of the wonderful articles that have been written by Victoria, by many of the other journalists who write for the science pages there. So much great knowledge about about the eclipse. And of course, just to remind everybody who's watching on the stream right now, I'm Cara Santa Maria. I'm a science communicator. I'm here with Terry Virts, a former NASA astronaut and space shuttle commander, and we are in the high desert here in Central Oregon, Terrebonne, Oregon, on this beautiful private property. You see this geodesic dome behind me. This was a prize. 2 lucky winners got to sleep in this Airbnb last night. They got to observe the night sky with a Nat Geo photographer and an astronomer, and early this morning they hopped into a private plane and they got to chase the eclipse. And this is what they saw, guys. They caught that first eclipse photo before anybody here was able to see it. Look how stunning. And Terry, what did you say before about this picture?
Well, it looks like a picture from the space station with the exception of the airplane wing being there, but it really looks like from space because it's this blackness of space and that thin blue line of the Earth's atmosphere. You could tell me that was a picture from the space station and I'd believe it. That's so jealous. What an amazing experience they had.
Absolutely. I've got to put my not my sunglasses, my actual glasses on so I can see it better. I just realized I haven't been wearing my glasses all day. Oh my gosh. Look at that. So these
What an experience.
I know. These 2 lucky winners from this incredible competition by Airbnb and National Geographic, they are up in this airplane chasing the eclipse.
They got longer amount of eclipse than we did because they're flying east. And although the shadow's moving 1,700 miles an hour, they're moving probably 500. So they got extra,
a little bit more.
Extra totality than we did.
Little bit more, and then of course NASA is up in some airplanes right now, and
Similar
they're able to get about 7 minutes of totality, which is just incredible. So yeah, we are here with Nat Geo and Airbnb, and we are looking for your questions, your comments, your stunning photography that you've been taking during the eclipse, and you can send it in to us using the hashtag NatGeoEclipse. You can also visit us on National Geographic's Facebook page. This is our live stream right now. You can see this is the sun with a partial eclipse. We're in third contact, which means totality has happened and it's passing through. Look at those sunspots.
Yeah, it's amazing.
Isn't that crazy? Yeah, and guys, if you're in partial eclipse, which most of America is right now, you can look directly at the sun so long as you have ISO certified safety glasses.
Yeah, you need to have protection, not like normal sunglasses are not good enough to stare at the sun. But if you have something that is certified for an eclipse, it is amazing to look up and see the sun. It's the sun kind of looks like a partial moon. Something took a bite out of it. It's incredible.
But it's really it's so funny how different the sun looks through your certified lenses. Whether it's sunglasses, whether it's binoculars, whether it's a camera with a filter on it. There are many ways that you can look at the sun during an eclipse, so long as they have this ISO certified filter on it that really protects not just your eyes, that's the most important point, but also the optics of your technology. The incredible thing is these filters are so dark that when you put them on, you can't see anything. I can't see my hand in front of my face. I think you're over here too.
No, I can hear you.
Okay. Yeah, we're over here. But when you look at the sun, it gives you enough filtration that you can actually see the brightness of it. And you can actually see, gosh, Terry, look up. You can see the corona. even with your solar glasses, because you're able to see those light rays coming out from it. So guys, we really do urge proper vision protection, and we really do urge everybody in the country right now to go outside and with these sunglasses, look up, all right? This is a once-in-a-lifetime experience. We say this all the time about the night sky. There's so much awe and wonder that you can get just by looking up. And now you get to do it during the day. Look up, and I promise you, especially if you're in the path of totality, disappointment will not be a word in your dictionary.
No, this is something you don't want to miss. If you're there, you need to see it.
I cried.
Yeah.
He saw it. You guys saw it. No. All right. So, guys, my director's telling me that they have that footage of totality. Not of me crying, but of totality. Here it comes. Check it out. Oh my goodness. Okay, so there's the diamond ring phenomenon, and it's starting to slowly evaporate. And now we're in totality here, and there's this phenomenon. I mean, it basically just looks like blackness to me, but you can see this super faint ring. There's this phenomenon called Bailey's beads. Terry, what are Bailey's beads?
So the moon is not this perfectly round surface. It has craters and divots in it, and as the sun's light flows around the moon, the craters allow certain areas of bright sunlight and certain areas that's blocked out. And so when you see in the seconds and fractions of a second, right before totality happens and right after it happens, you can see basically the shape of the moon being reflected around the sun. It's a pretty neat way. It looks like little beads around the sun.
It's just stunning. And the cool thing is that when you see these totality photos, then, and you mentioned you think this is going to be the most photographed event ever.
Well, this is generating so much interest. Some people are predicting that it will be, and it's going right across America where everybody has a cell phone.
Yeah.
Lots of people have cameras. And it's going to be exciting later on to see what's on Twitter and Instagram and see what kind of pictures people post.
Absolutely. And the cool thing is, you know, sometimes when it comes to eclipse photography, it's all about the timing.
Right.
And so because so many different people have been able to take these images, we can compare not just for our pleasure and our enjoyment, the way that the sun looked at different phases from different places, but we can also enjoy, like, from a scientific perspective, we can really get some great data. And right here, guys, you can see totality is just ending, and there's that diamond ring phenomenon once again. And at this point, through the telescope, you can't really tell, but to your naked eyes, this is blindingly bright at this point. That is when you have to put your solar protection back on.
A few seconds after totality, and it's too bright to stare at it.
It's too bright to look at it. It's just, it's crazy.
Back to sun.
Absolutely. Okay, let's see. Okay, so we've got a couple of questions here, and a couple of these we've answered earlier in the stream, but I think they're pretty important and they bear repeating. We've got a question here from someone who says, does this happen with other planets? And as we explained a little bit before, other planets can't fully block the sun when they pass in front of it. They do transit it. There's something called the transit of Venus, and it goes in front of the sun, but it's teeny tiny little dots.
It's a little dot, yeah.
There is a shift in brightness, and scientists can measure it. We can actually see it using proper eye protection, but you don't get this experience.
So you've read in the news about discovering planets in other star systems, and that's actually how we determine that there's a planet, is that when it passes in front of starlight, it clearly is not creating an eclipse on Earth, but the brightness of the star dips a little bit from the planet blocking that star's light. And that's how we're detecting planets right now, is with basically the answer to that question is how we detect planets.
How cool is that?
Cool. Yeah.
And then if we were to answer this question a different way, does this happen with other planets? Maybe we could say, does this happen on other planets? Because we've got another question that says, if we might be living on Mars someday, can we experience the eclipse from there too?
Well, we wouldn't be having this special National Geographic presentation because it happens all the time on Mars. Mars has two moons, Phobos and Deimos, and they are very small. They're really odd shaped. They're basically asteroids that are in really close orbit to Mars. And because they're so close to Mars, their shadow gets cast on the Martian surface very frequently. and it's not the super rare once-in-a-lifetime event that it is here.
But it makes me wonder if it would be as pretty, right? Because our moon is almost round and the sun is almost round. So we
Right.
get this really stunning ring phenomenon. And on Mars, as you mentioned, the moons are sort of rocky and asteroid, like they're lumpy.
Right, they are lumpy. And you know, it would depend, the amount of totality would depend on, is the moon passing in lengthwise or is it the skinny wise? You know, there would be a big difference in how much eclipse you get on Mars.
And of course, totality might just be that the sun's so obscured that you're only seeing the faintest little parts of the tendrils of the corona. Ugh, guys.
That would be cool to see one on Mars. Hopefully someday soon in the not too distant future.
It would be
people
cool,
will be
but
seeing it.
I don't want to undercut how cool today was.
It was, cool's not the word. I don't think there's a word to describe it.
You know what the word
was
is?
Amazing.
The word, we overuse it all the time in the English language and it bums me out, but this is a perfect example. It was awesome.
It was awesome.
It was awesome. Like,
awe-inspiring.
it inspired awe. It made me cry. This is the live view right now from our partial eclipse. So we are past totality. We've almost got a full sun again. But of course, our telescope is so powerful that you can see sunspots, which is so incredible. But I think it would be fun. Let's just one more time, for those of you who are just tuning into the stream, to show the totality event in all its glory one more time. So if you look here, you can see that the diamond ring phenomenon is just being eclipsed.
Blanked out, right?
And now we're in totality. Now, during this portion of totality, let's talk a little bit about what happened. What was your experience like?
The first thing you notice is it gets dark. You know, maybe 10 or 15 minutes before it started to get gray. And it wasn't a normal sunset dark like you mentioned. It was more just gray. And then it got cold. We were
really cold.
It got really cold. It was goosebump cold
Yeah.
here in the high desert. The temperature really changed. And then people started screaming and shouting and hooting and hollering. And when it actually happened, it really surprised me to see the sun, the corona. I didn't realize how big. Naked eye, it was a gigantic piece of sun's atmosphere that you could see.
Yeah, sometimes when you look at pictures, and even when you look at this telescope stream, which is so dialed in and so big, you see this tiny little sliver. But with your naked eye, the corona extends far out from totality.
Right. And another thing, looking at the moon, there was one bright yellow or orange dot on the right as we looked at it, kind of on the south. And I don't know if that's related to Bailey's beads or not.
Could have
but
been
it
a
was
Bailey's
cool.
bead, yeah.
But the seeing the corona, I think for me was the most amazing thing.
Yeah, I think so too. And also, for me, just looking down and around, noticing all of the wonderful crew that's out here with us from National Geographic, from Airbnb, seeing them looking up and just gasping at how incredible it was. You can see here from the feed, this is when totality is just finishing. You definitely see Bailey's beads popping through, and eventually there is that diamond ring phenomenon that occurs one more time. It's just, guys.
There was a ghostly shadow too on these mountains. It was like a ghost shadow.
And the funny thing is, the word umbra, which is that central cone, that central shadow, actually means
ghost.
Yeah. And penumbra, which is the larger shadow that's cast by the moon that you see during a partial eclipse, like what's happening right now, that term was actually coined by Kepler. That's a famous astronomer.
He is?
He is.
That's right.
Yeah.
That's amazing.
Just a little tidbit there. Guys, this has been so much fun. Sorry, a bee came to say hi. This has been so much fun. Terry, I couldn't have asked for a better partner in crime for experiencing the eclipse.
This was a once-in-a-lifetime experience. I completely loved it. I've wanted to see one ever since I was a kid, and I always thought, it would be cool. It's way beyond cool. I mean, it was really impactful. And it's something, right now, almost all of America is in some form of partial eclipse or total eclipse. So I think it's something that can bring us together. It's something that every American is going to experience in a very positive way, which may be the best thing that happens out of this whole event.
Absolutely. No matter your differences, we're all underneath the same sky, and we get to experience this together. I want to thank you, former astronaut, Space Shuttle Commander Terry Virts. I want to thank National Geographic. I want to thank Airbnb for this incredible opportunity. And I want to thank everyone at home for tuning in. And let's keep the conversation going. You can go to National Geographic's Facebook page, and on Twitter, Instagram, wherever. Make sure that you use the hashtag NatGeoEclipse to share your stories and your photos. Happy eclipsing, you guys. It was so good to be with you.
That's right.
Now, these different phases require different types of protection, so maybe we should do a quick safety
They do.
lesson.
We'll do a demonstration.
Yeah.
So don't do this unless you have some approved glasses on, but I'm going to actually look at the sun with the approved glasses, and you can see, it's amazing. You can see the moon has taken a significant bite out of the sun right now with our
Wow.
glasses.
Well, I have to just point out real quick that my safety glasses are a little cooler than his
Yes,
safety glasses.
again, bragging rights. I'm losing all the bragging rights here.
And we should mention that they need to be ISO certified glasses.
That's
there
right.
are some fakes out there, which is a huge bummer. Why would somebody do that?
These are not normal sunglasses.
Yeah.
So, and also when you're in a partial eclipse, it doesn't make the sun any worse. It's not more dangerous than it is on any day. But on a normal day, you're not going to stare at the sun. And when there's an eclipse, you're interested to see what's going on up there. That's why it's more dangerous. It's just the likelihood of you actually staring at the sun.
Absolutely, and the closer and closer that we get to totality. So if we look at our live stream right now of the sun, you'll see that it's a big bite has been taken out. The moon is really covering a bunch of the sun, but as it gets closer and closer to the sun being a sliver, it might not feel as much to your eyes like it hurts if you tried to look at it. It might not feel as bad. And that's when it's the most dangerous because you won't have that natural inkling to squint. And you should never look at the sun. The sun is way too bright. It will damage your eyes. So
even
eye
if
protection.
it's 90% covered.
Exactly.
Even if it's mostly covered.
90% covered, you cannot look at it without eye protection. You want these ISO certified glasses. There are also some cool toys out there, and maybe you already have them. It might be too late to get them if you don't. Like, I have a pair of solar safe binoculars, so I can actually turn up and look directly at the sun. Oh my gosh, and I can see sunspots. I'm freaking out right now, you guys. I'm going to be doing this quite a bit throughout this stream because I can't get enough of it. I can look directly at the sun with my binoculars. Terry's doing some incredible photography right now.
That's right, but I have a special solar filter on the front, so you do not want to look through a normal camera at the sun because that will be even worse than looking at the sun. It'll be like a magnifying glass focusing those dangerous sun rays.
You remember doing that with a magnifying glass with ants when you were a kid? Ooh, but we all did that.
Yes, we did. So you don't want to do that on your eyeball.
No, absolutely not.
And if you happen to be in that narrow band of totality, once the sun is completely blocked and the moon is covering it up, then you can take your glasses off and it'll be safe for a minute or 2 minutes, however long you're in the path for. But until then, you have to have the protection.
Yeah, and so look it up, make sure you're in totality, and you'll know. I mean, it's a very specific look, being in totality, but that's the time when you can actually remove your eye protection. You can look straight at the sun because the sun is completely blocked by the moon, and all you can see is that faint corona. And the truth is, if you try to look at the sun with your protection, because these are so dark, during totality, you actually won't be able to see anything. That's the moment. It's when the sun sets in the middle of the day. This is what I think a lot of people don't realize. In totality, it's going to get dark.
It'll be dark. It'll be cooler. The temperature will drop. Yeah.
Oh my gosh, I am so excited. Okay, so you have never, you know, the last solar eclipse was in 1979 here in the United States. And so I've never experienced it. I was born in 1983. Have you experienced from the ground here on Earth a solar eclipse?
I have not. This is my first one.
But a little birdie told me that you have seen them from space.
So that was a really amazing opportunity. When I was on the space station 2 years ago, there was an eclipse over the North Atlantic. And as we were flying over, it was really far in the distance. It was more than 1,000 miles away. But you could see actually the shadow of the moon on the Earth. And if you look at this picture, there's a solar array from the Russian Progress spaceship there. So underneath that bright white rectangle, you can see the dark spot. And that is actually the moon's shadow. And it was so amazing to be in space, looking at my planet Earth in the distance and seeing the shadow from another heavenly body. It was truly
Hello, Hi, everyone, and welcome to this momentous day. It is the Great American Eclipse Day, and we're here with National Geographic and Airbnb on this live stream on Facebook, YouTube, and Periscope. My name's Cara Santa Maria, and I am a science communicator. I'm here to help communicate some of the science behind what's going on. But even more interestingly, I am here with a NASA astronaut. Tell them about yourself.
Well, my name's Terry Virts. I'm a former NASA astronaut and National Geographic author, and so excited to be here. It's amazing.
I am thrilled. Okay, so today is Eclipse Day across all of the continental United States, and we have some really fun stuff going on. This is going to be my conduit to you guys at home. I'll be able to answer all of your, not all of them, some of your questions that you send in. I know we're going to be a little overwhelmed with them. I'll be able to go through and see what you guys have to say, and we'll be able to read some of that stuff on air. Now, I do want to point out that there is a big difference between a total eclipse and a partial eclipse. We're in the path of totality.
Yeah, this is amazing. We're right almost in the middle of that path of totality. As the moon goes around the Earth, it casts a shadow, and the shadow is pretty small. It's only about 40 plus miles across. And when you have a total eclipse, that shadow goes right across the Earth's surface, and that's where we're going to be in just a matter of minutes.
I am thrilled. We're here in Terrebonne, Oregon, and right now we are in the phase of the eclipse between what they call first and second contact. We're actually already in a partial eclipse, and we have a live feed of that. You guys can see what's going on. The moon is already covering much of the sun there, and you can even see sunspots through this live feed.
It's amazing.
How incredible is that? All right, but I do want to talk about why we're here in this beautiful location, which feels like it's the middle of nowhere. It's in the middle of nature. You can see that there's this geodesic dome behind us, and this was a special prize for two very lucky Airbnb customers. So they got to spend the night in this geodesic dome, and then today they got to fly with a Nat Geo photographer and with an astronomer to chase the eclipse. So first they're in, really? Oh yeah, you live in Houston.
In Houston.
Astronaut. So we do have another opportunity if you're missing it today. And also, maybe we should talk a little bit about the different ways that you can look at an eclipse. Because
That's right.
most of you watching on the stream are probably not in the U.S., or if you are in the U.S., you're not in the path of totality. So you're seeing a partial eclipse. It's a very special thing to be within that path of totality. I think you were telling me earlier, 1 in 1,000 people?
Yeah. I've seen the statistics, less than 1 in 1,000 humans ever get to see a total eclipse. So you're pretty lucky if you do. And even if you're in the path of totality, if it's cloudy, you're going to miss it.
That's true. There's some cloud
there's
cover
some cloud
today in some
coverage,
parts
yeah.
of the country.
Yeah.
So hopefully they'll be able to enjoy it here on the stream because we
Right.
have this wonderful telescope that's really powerful with a solar
amazing.
filter trained on it. So you can see, oh my, it's so crazy that you can see sunspots. It just blows my mind. But also the moon is occluding it. And something that I notice when I talk to a lot of people who have seen total solar eclipses is that you can't tell that it's the moon during the day, right? Because the sun is so bright that the moon, Terry's taking some photos, he's gonna be doing this throughout, that the moon, it really looks like this dark disk, almost like a hole in the sky. And as the moon actually covers it up, sometimes people get scared. They actually feel like the sky has ripped open and there's this hole that's coming at them. It's a very visceral experience. I have no idea what I'm gonna do. I might cry, just to warn you. I might cry, I might scream, I might be afraid. And also, did you know that animals act super weird during eclipses?
They do, yeah. They don't know what's happening. They think it's nighttime all of a sudden.
And so I was reading up on this. Dogs can sometimes get really scared. You'll hear that birds will roost. They'll actually go to bed for the night. Roosters will cock-a-doodle-doo when the sun comes back out because they're like, what is happening? But two things that I found super fascinating. Apparently cows don't notice. They just don't seem to have a reaction. And they found this out. Yeah, they found this out by doing a lot of cool citizen science during I think there was an eclipse in like the 1930s. And scientists asked people to watch their animals and take notes and write in and tell them what happened.
Wow.
And cows don't seem to notice. Chimpanzees, our closest cousins, will look up and actually
See what's
look
happening.
at it in awe.
Without glasses, though. That's the problem.
That's a huge bummer. They don't know about ISO protection.
That's right.
Oh, we need to get the chimps some
We do.
solar glasses. Oh, we need to start a new nonprofit
Right.
for that. So crazy. Animals are going to act strange. I think people are going to act strange. You know, we're here in Central Oregon where there's a lot of eclipse parties going on. Nearby in Madras, there's a big tent city basically happening where a lot of people are watching. And there's probably a lot of kind of discord outside during the eclipse because when you're in close proximity to a lot of people and you have these sort of visceral reactions, I can't imagine the interesting noises people are going to make.
My friend, fellow astronaut Don Pettit is in Salem, which is on the west coast of Oregon, and the Oregon Science Museum is doing an event with 9,000 people. So he's going to be helping to host that. But we were talking last night about how he's going to film it, and he wants to film it with the noise so we can hear people's gasps and reactions. Yeah,
absolutely.
That's going to be cool.
Okay, so I just realized too that Brenda, we didn't fully answer your question. What effect, if any, will the eclipse have on Earth's tides? I would say don't quote us on this because neither of us are eclipse experts, but I don't think it's going to have an effect. It's basically a visual fluke, but the moon's in the same position it would be in anyway. Maybe we can talk a little bit about the cycles. So we mentioned 375 years, an eclipse will pass over the same spot.
Right.
Although there is an X marks the spot place on the map. I can't remember where it is, but if you live in this one town, you actually get to experience both total eclipses.
Oh, cool.
Lucky you. And so let's talk a little bit about the Soros cycles.
That's right, a surreal moment in space.
I can only imagine. And of course, you've taken how many photos from space?
I took over 300,000. I took a lot of pictures.
How is it that you don't have a coffee table book for my enjoyment?
Well, funny you should ask, actually. I have a book called View from Above. It's a National Geographic book.
Oh, great.
And it comes out this October. So it's a combination of some of the best of the, not all 300,000 pictures, but 300 of the best. And also stories from space, what it was like to be there for launch and landing, what it was like to be there during some emergencies that we had. So it's a combination of stories and photos that kind of take a space mission and put it in book format.
So you said it comes out in October?
October 3rd.
Just in time for my birthday. Just, just saying, October 19th. And the reason it's an easy thing to remember for me, totality, right where we are, starts at 10:19 this morning, which is my birthday. And right now, I'm just going to check, it is 10:42. So we're getting really, really close to totality. Can you believe it?
Another,
I said 10:42.
9:42.
But I meant 9:42.
Another 40 minutes or so.
Another 40 minutes or so, and I'm going to be doing a countdown. I have a great app on my phone that gives me a perfect countdown to totality. So we'll be doing a nice countdown. I know that Terry is going to try and get some good astrophotography.
Yes.
Would you call this astrophotography?
I think
it's like solar photography.
Yeah, there's probably a special name for it.
Exactly. So he's going to try and get some really cool photography while it happens. I think I'm just going to appreciate it.
Enjoy
but
it.
We will work on that countdown. So I want to maybe take a question from the audience here. You guys at home, of course, keep sending in your questions, your comments, because we're going to be able to check in with you throughout the stream. And remember, you can do that at National Geographic's Facebook page, or you can do it by using the hashtag NatGeoEclipse. And I've been using it, so you should use it too. All right, so we have one here from Brenda Troyer Harness, and she asks, what effect, if any, will the eclipse have on Earth's tides? Oh my gosh.
That's a great question.
But you know what? Here's the thing. The moon is in this fluky position anyway.
Right.
So it's a normal day for the moon, and it's a normal day for the sun. But there are some numbers that we should know, right?
That's true.
The Earth is, let's see if I get this right. You fact check me here. The Earth is 4 times larger than the moon.
Right.
The sun is 100 times larger than the Earth.
Correct.
So the sun is actually 400 times larger than the moon.
Right.
But the moon is
400 times
closer.
Right.
Yeah, than the sun, which means if the sun's 400 times farther away, but the moon is 400 times closer to the sun, in this super fluky coincidence, the moon looks like it's the same size as the sun and completely blocks it.
It does, for now.
For now.
But soon, in another 600 million years.
Soon, he says.
The moon actually moves away from the Earth a few inches a year.
No, it doesn't.
A couple inches a year.
That's amazing.
So in 600 million years, it'll be so far from the Earth that there won't be any more eclipses. So it's good to watch the eclipse while you still can.
Yeah, so when we say once in a lifetime, but really it is in many ways a once in a lifetime because eclipses are quite common. There's about 2 a year. They're usually partial. There's one total solar eclipse. What is it? About like every 3 or 4 or 5 years.
Every year or two,
like that. Yeah. It does happen, but the problem is it's usually over the ocean.
Right.
It's not where you are.
Right.
And it's not usually in your country. So the same eclipse, like this eclipse that's happening today, or I shouldn't say the same eclipse, that gets confusing. An eclipse passing over the same GPS coordinates only happens like every 75?
No, it's over 300.
375 years. Which means if you never move, like if you don't have the capacity to travel to see an eclipse, this is it. This really is a once-in-a-lifetime experience. We do have another total solar eclipse coming to the United States in 2024. So that's just in, what is that, 7 years?
A few more years, yeah.
Oh my gosh. And it's going to pass over where I grew up in Dallas, Texas.
Cool, that's right. It'll be
really
in
excited.
Texas, where I'm from.
To go in a helicopter, and then they're going to be in an airplane where they get to follow the eclipse.
So jealous.
Yes, so freaking jealous, right? And you can see them here. How exciting. Oh my gosh, such excited winners. I can only imagine what it would have been like to, I wish I had slept here last night.
I know, what an amazing place out in the high desert.
Yeah.
The stars must have been incredible.
I know.
It's beautiful.
But I gotta be honest, I stayed in a pretty dope Airbnb last night too.
It was pretty awesome.
Yeah, it was a lot
very
of
nice
fun.
house, yeah.
So I'd love to check in with Jedida Eisler, Dr. Jedida Eisler, who is the astronomer who went up in the plane with them, and Babak Tafreshi, who is the Nat Geo photographer. Let's see what they have to say.
Hey y'all, it's Dr. Jedida Eisler. I'm an observational astrophysicist and a lover of the night sky. I'm so excited about what's gonna happen.
Babak Tafreshi, I'm a night sky photographer working with National Geographic and the founder of the World at Night program. So the whole life I was involved with night sky and a fan of astronomy.
So it's almost like we're doing the coolest thing one could do if one were going to watch a, say, once in a lifetime solar eclipse. We're going 35,000 feet in the air to watch the eclipse in a private jet. Are you excited?
Yeah, that's the best place, I think, to see the coming shadow and the going shadow. And it's much faster than our plane, almost 6 times faster.
Yeah, it is. Yeah, it is. There's no way we're going to keep up with it. So all of those of you who are excited for us, we're excited too, but we're not going to be able to go with the shadow. It will pass us very quickly, but we'll still get a very unique vantage point that we're really excited to see.
Yeah, I think we get 15 to 20 seconds more totality by being on the plane, chasing the shadow. So it's slightly more than the ground. But the main benefit, I think, it's just to be among the first people to see it. Probably less than 10 minutes before the others on the Lincoln Beach.
I love it. I love it. Yeah, I think that's true, right? Getting to see it early is always fun. I would watch it at any time, but if I could watch it at 35,000 feet, I will.
Every eclipse is different depending on the ambient environment that we're seeing. It could be with some clouds, reflection of the clouds, colors in the clouds. It could be the shadow coming, could be people and their emotional reactions. So I'm going to include many of those in the opportunity we are going to have on the plane. We have guests, and probably it's their first total solar eclipse, so I'm going to capture those emotions, as well as close-up of the eclipse. As I said, you know, those streamers coming out of the solar corona are better visible from our altitude.
They are.
But my main aim would be to capture this shadow coming, especially when you're up in the air, you see the cone of the shadow much more clear than being on the ground. So all these together, I think it will be a very diverse total solar eclipse for me.
So the next time you see us, we'll be 35,000 feet up, looking directly near the sun with our protective glasses on. We hope wherever you are, you get a chance to watch it or experience it in some way. It'll be fun. See you soon. Bye!
Oh my gosh, so excited. I'm really jealous that
I'm
they're
totally
up there
jealous.
in that plane right now.
They will have bragging rights.
They will absolutely have bragging rights. Okay, so let's recap a little bit of what they mentioned. During a solar eclipse, it's really quite a simple concept. It's that the moon is in front of the sun.
That's right.
And we happen to be in that path, which is, there's a fun word for this. It's called syzygy. Syzygy. I said it wrong. I always say it wrong. Syzygy. And that's when the planetary bodies align just so perfectly. And most of America is actually in what they call the penumbral shadow, which is the almost umbral shadow, the large shadow that's cast down. And that happens during a partial eclipse. Most of America is in a partial eclipse. There's a skinny line, you said earlier, 40 plus miles across. That is the totality line where you'll be able to see the sun, or the sun be completely blocked by the moon.